Everyone, and a very good day. So here, this is the first chapter of Econ 2111, Intermediate Microeconomics 2. So before I explain more about this chapter, let me brief a little bit about Intermediate Microeconomics 2. What you're gonna see in the Intermediate Economics 2 is basically all about the firms and market. But not only those things, we also have the study or the analysis on, the government and market failures, as well as, a bit of the international trade as well. Okay, and now let's crack on. So when we talk about, when we want to look at chapter 10 here, we want to look at the market power, monopoly, and monopsony. So these are 1 and 2. Okay, now when we talk about market power here, what does it mean by market power? But let's do some what we call revision. Okay, so I'm sure you have heard the term monopoly and market power. Perhaps some of you have heard the term monopsony. Now, in the study of market, okay, I'm sure if you can recall back your principle of microeconomics, you have about 4 different types of market. Okay, so these 4 different types of markets can be divided into 2 groups: perfect and also okay, perfect market. So perfect market, the main here is what we call pure competition. Okay, so perfect competition of pure competition. So I'm sure you have seen the graph and the way to maximize profit and what happens in the short run and long run for pure competition. When we talk about imperfect market, so it means there are 3 different types of market. Markets here fall under this category. So the first one is of course monopoly, and that the second one here is monopolistic competition. Yeah, and third one here is oligopoly. So if we have all of these 4 here, what about monopsony? Okay, now let's look at these 3 terms one by one. Monopoly is very simple. It is a market. So when we talk about market, we have demand and supply, and we have buyer and seller in it. Now, in monopoly industry or market, okay, we only have one seller, but we have many buyers. So that's why in your principle of microeconomics, you understand that when we have monopoly, when we have one seller, the seller tends to increase the price, to charge higher price to maximize profit, because the seller can monopolize all of the customer because they don't have any choice to buy except from this seller in it. Now, what about the monopsony here? Monopsony is nothing else but the opposite of monopoly. We will talk more about monopsony once we finish with our study on monopoly. And what about market power? Number 3 here. Market power is actually the ability of the seller or the firm to manipulate the price in the market. Okay, it doesn't mean that when you have market power, you can do anything you want without certain constraints. You can manipulate price, but you still have certain constraints. So what are those constraints? You're going to see more in the later slides. Yeah. Now, let's look at the mechanics or the technical parts of monopoly. Now, when we talk about monopoly, then we want to see the characters of monopoly. And the characters of monopoly, when you learn in principles of microeconomics, it can be explained using 2 different ways. The first one is using graph, and the second one using mathematics. Now, I'll show you the simple maths here first before you go into detail on more sophisticated maths. Then I'll show you the graph. So all of these are just revision because I'm pretty sure you have seen it before in the principle of microeconomics. Now, so we want to look at the technical part of monopoly or any kind of markets, be it perfect market or also imperfect market. Then we want to look at the average revenue and also marginal revenue. So what does each of these terms mean? So in order to understand this, we have to look at the exercise, simple exercise here. Now, in this simple exercise here, we also want to look at the relationship among total, average, and marginal revenue, and considering that the firm is facing this kind of demand curve. Okay, so demand curve is shown, demand equation or curve is shown in equation 1 here. Okay, so price is equal to 6 minus Q. Now, mathematically, if you reverse it, then you can have Q is equals to 6 minus P, isn't it? So this one is correct, this one is also correct, but this one is price as a function of quantity. This one is quantity as a function of price. Now, have you heard the term of direct demand and also indirect demand? Okay, now you have A here, you have B here. So which one is direct demand and which one is indirect demand? Can you figure it out yourself and take this question seriously? Okay, now let's go back to our main objective because we want to look at the technical part of monopoly. So we're going to look at this technical part by looking at the simple maths first. So we have the price here and we have the quantity. So this is the first column, second column, the third column, the fourth column, and the fifth column. Now in the first column, we list down all the available prices from high to low. And in the second column, we list down all the available quantity from low to high. Then you can see, based on first column and also second column, price and quantities are negatively related. How do you know? As price decreases, can you see here from 6 to 5, 5 to 4, and so on and so forth, then you can see quantity demanded for this product sold by the monopoly firm or seller becomes higher and higher. Now we have negative relationship or inverse relationship between price and quantity because this is nothing else but just a law of demand. Now, from price and quantity, it can facilitate us in calculating the total revenue. Now, the total revenue, what's the formula for total revenue? It is nothing else but price times quantity in it. Alright, now, for the first one here we have 6 times 0, which is 0. Second one, 5 times 1, which is 5 in it. 4 times 2, 3 times 3, 2 times 4, and then 5 times 1, isn't it? So here 8, 9, 8, 5. Okay? Now, what about marginal revenue here, class? Okay. Now, marginal revenue is nothing else. Okay. But the additional revenue that the seller can obtain by selling one additional unit of quantity or product he or she sells in the market. Now, in this case, in particular, monopoly market, okay, or industry. Now, how to calculate marginal revenue here? I'm sure you have learned this in Principle of Micro, and the calculation is very simple. So, marginal revenue is nothing else but the change in total revenue divided by the change in quantity in it. Now, let's look at the first one. We have 0 quantity, we have 6 price, so we don't talk about this because it needs change. Okay. Now, what about the the first quantity here? The first quantity is total revenue is 5. Okay. The new revenue is 5 minus 0 revenue from the previous, unsold item divided by quantity 1 minus 0 quantity, isn't it? So in this case, equivalent to 5. So this is marginal revenue when price is 5. Okay. For the second one here, okay, it is 8 minus 5 divided by what? Divided by 2 minus 1, which is 3. So marginal revenue, when the price is 4 and quantity is 2, it becomes 3. And then the rest, this one becomes 1, isn't it? This one becomes minus 1. This one becomes minus 3. Okay, so when price becomes 1, okay, falls down from 2 to 1, the marginal revenue falls down even further from minus 1 to minus 3, isn't it? Becomes smaller and smaller. All right, now what about average revenue? Now, average revenue calculation is very simple. Average revenue is equivalent to total revenue divided by quantity, isn't it? Okay, so in this case, okay, for the first one, we don't sell anything, so we don't earn anything. When we don't earn anything, we don't have calculation of average revenue. Simple. Okay. Now, when we have quantity 1, when we have price 5, then what is our average revenue? Our average revenue is total revenue 5 divided by quantity sold 1 equivalent to 5, isn't it? Okay. What about the second one here? Okay. Total revenue is 8. Okay. Divided by quantity sold is 2. So it becomes 4. And the rest, this one becomes 3, 2, and 1. Looks so simple, isn't it? Can you see what happens to average revenue here? Average revenue from 5 to 4, 4 to 3, 3 to 2, 2 to 1. Now, when average revenue is 5, price is 5, isn't it? When average revenue is 4, price is also 4 at quantity 2. Now, when average revenue is 3, okay, price is 3, isn't it? 2, 2, 1, 1. Now, what can you say about the relationship between price and average revenue? They are the same, isn't it? Now, let's go back to the total revenue here. As we can see, when the price falls down from 6 to 5, 5 to 4, 4 to 3, 3 to 2, and so on and so forth, quantity increases because this is law of demand. And what happens to total revenue? Total revenue increases from 0 to 5, 5 to 8, 8 to 9. Okay, but then falls down from 9 to 8, 8 to 5. Okay, can you see? So total revenue first increases and then up to certain point, okay, where price is 3, it reaches maximum at 9, but then falls to 8 when price falls down even further below 3. Okay, so total revenue increase and then decrease, isn't it? Okay, now, but what about marginal revenue? 5 to 3, 3 to 1, 1 to minus 1, minus 3. Okay, now you look here. When we sell one quantity, marginal revenue is 5, price is 5, isn't it? When we sell two quantity at price equivalent to 4, marginal revenue is 3, isn't it? You compare price 4 with marginal revenue 3, which one is greater than which one? Price is greater than marginal revenue, isn't it? Now, when we sell 3 from 2 to 3, price decreases further from 4 to 3, isn't it? All right. And then what happens to marginal revenue? Falls from 3 to 1. And if you look at 1 here, compare with price 3 is bigger than marginal revenue 1, isn't it? Marginal revenue minus 1 is smaller than price 2. Marginal revenue minus 3 is smaller than price 1. What can you say about comparison or relationship between price and marginal revenue? price is bigger than marginal revenue, isn't it? Okay, so these two things you must have in your mind so that you can understand more about the characteristic of monopoly. Okay, all of these can be depicted in the form of graph. Let's continue with the second method of looking at monopoly average and marginal revenue. So the second method here is basically the graphical method. Now, in order to show the average and marginal revenue in the form of graphs, then why don't we use this demand function again? So we have P equivalent to 6 minus Q. Okay, so this is indirect demand function. I'm sure you have heard this term again, indirect demand function. Can you change it to the direct demand function? Okay, you should try it at home. Okay, now recall back our objective is to draw average and also marginal revenue graphs. Yeah, so here how to draw it? Given this equation, okay, so we need to find total revenue. Okay, so we have total revenue, which is price times quantity, isn't it? So we have price, equation 1. Okay, so how to get total revenue? So equation 1 times quantity, which is, okay, in bracket 6 minus Q times Q. And therefore, this gives us total revenue equivalent to 6Q minus Q square, isn't it? This is just a simple math. But we haven't reached, the equations or the function of average and marginal revenue. Okay, now from total revenue, we can get marginal revenue. But what's the difference between total revenue and marginal revenue in economic terms? I'm sure you have heard this definition. When we talk about marginal revenue, it is the additional revenue that seller receives when he or she sells one additional unit of output. Okay, so in mathematics, the additional revenue or marginal revenue can be obtained from some calculus of total revenue. What is that? Okay, so marginal revenue is basically the differentiation of total revenue with respect to Q. Okay, so in this case, you need to recall back your business maths. Okay, now we need to differentiate this total revenue function, I call it equation 2, with respect to Q. So 6Q becomes 6, okay, Q square becomes 2Q. So this is our marginal revenue function. Yeah, okay, now, so we have equation 3. If we have equation 3 like this, then it helps us to draw marginal revenue function. But before we draw marginal revenue function, we also need to find average revenue function and then draw it. Okay, we are going to draw marginal revenue and average revenue in the same graph, but before we draw, we need to do some calculus here using the original indirect demand functions. We have obtained marginal revenue function from equation 1. Now let's obtain average revenue function from total revenue. Now, what does it mean by average revenue? Average revenue is the revenue that seller receives after selling one unit of product. Okay, for every unit of product, the amount of revenue seller receives is what we call average revenue. The amount of revenue. See the difference? Initially, when I told you about marginal revenue, the amount of additional revenue. Okay, so marginal revenue is additional revenue for one unit of product. But if it is average revenue, it is the the revenue received for every unit of product sold. Okay, now, so how to find average revenue? Recall back, we have found total revenue, which is given by 6Q minus Q square, which is given by expression 2. So from total revenue, okay, we want to get average revenue. Average revenue is nothing else but total revenue divided by quantity. Now, use equation 2 or expression 2, 6Q minus Q square divided by 2, isn't it? So, you're going to have here 6, okay, minus Q, okay, which is average revenue. So, this is equation 4. Now, can you see that if we look at equation 4, isn't it similar to equation 1 or the indirect demand function? Yes, it is similar. Therefore, we can conclude that average revenue is actually equals to price or demand for monopoly here. Okay, now next, let's go back to our objective. We want to depict monopoly average and marginal revenue in the form of graphs. So we already have marginal revenue in expression 3. We already have average revenue in expression 4. So let's draw average revenue first. Okay, so of course, you must have vertical axis. Also, you must have horizontal axis. Horizontal axis is for quantity Q. Vertical axis is for monetary term P. Okay, let's draw average revenue curve. So for any curve, a basic drawing is that, okay, we need to know whether it is a curvy curve or a straight line. Okay, we also need to know whether it has vertical intercept here and also horizontal intercept here. We also need to know whether it is upsloping, downsloping, or both. Okay, so how to do this? Now first, we need to check whether it is curvy curve or a straight line curve. So let's go back to average revenue function. I want to draw average revenue function. Average revenue, let's recall back 6 minus Q, isn't it? So this is average revenue. How to know whether it is upsloping or downsloping? Then mathematically, we need to differentiate average revenue with respect to Q. Then from 4, when you differentiate 4 with respect to Q, it becomes minus 1, isn't it? Now you look at minus sign here, it gives you the indication that average revenue is negatively related, isn't it, in terms of graph, and therefore it is downsloping. Now, downsloping can be something like this, can be something like this, okay, can be something like this, okay, or can be something like this. The first one here is straight line. The second one here is not a straight line, it is concave. The third one here is convex, but also downsloping. 1, 2, 3 here are all downsloping. So for average revenue here, it refers to which one? Yeah, is it 1, is it 2, or is it 3? How do we check it? Okay, now we have 5, yeah, okay. We did it from 4, therefore we know the average revenue is downsloping. That's why we know that it is downsloping. Okay. In order to decide whether it is number 1, number 2, number 3, recall back business maths. You need to differentiate average revenue with respect to Q for the second time. Okay, so that means you need to differentiate expression 5 here. Do you see any Q in 5? No. So what happened is that if you don't see any Q, when you differentiate it with respect to Q, the answer is 0, isn't it? Okay, now what does it mean here? Average revenue is downsloping because of the minus sign in 5. When the minus sign, it is downsloping, the slope is less than 0, isn't it? And you look at number 6 here, the one that we have found just now. When you differentiate it again for the second time with respect to Q, then we got 6 and we have 0. What does it mean? It is downsloping and it is straight line. Okay, so it is straight line. Now, that means the graph should look like number 1. Okay, for average revenue. Okay, now, recall back what did I say to you just now? In order to draw average revenue, we also need to check whether it has vertical intercept and whether it has horizontal intercept. Okay, now, how to check whether it has vertical intercept or not? This is very basic maths that I'm not going to tell you. So yes, it has vertical intercept. It is 0, 6, yeah, the coordinate. Does it have horizontal intercept? Yes, it has. It is 6, 0. This is for average revenue. You must show how to get 0, 6, how to get 6, 0. Yeah. Okay. Here I don't go into detail because all of these have been learned in business math. So 0, 6, and then 6, 0. So you have 2 points. You join the 2 points, you get the average revenue curve or demand curve or price curve. Yeah. So we are done with average revenue. Next, we need to draw marginal revenue curve in the same diagram here. Okay. So what you need to do is to check the slope. Okay. So you must find, okay, DTR. Sorry, yeah. So I erase this. So we must find the slope of MR with respect to Q. What do you get? Minus 2, isn't it? From 3, you differentiate 3 with respect to Q. You differentiate MR with respect to Q, then you get minus 2. Okay, minus 2 is less than 0, therefore it is downsloping. Like I said earlier, downsloping can be number 1, number 2, or number 3 here, isn't it? So which one? You need to differentiate it once again. Okay. And what do you get? You don't see Q here. Okay. Let's call this one number 6. Yeah. Equation 6. You don't see Q in 6. So when you differentiate it again with respect to Q, the answer is 0. Therefore, the graph is a straight line. Okay. The graph is downsloping because the answer in 6. The graph is a straight line because of the answer in 7. And you must draw it here. Therefore, it's number 1 also. Looks like number 1. But we need to check whether marginal revenue has vertical intercept or not. Whether marginal revenue has horizontal intercept or not. Be careful. The one with P here is the vertical axis. The one with Q here is the horizontal axis. Okay, if you check it, then you will get that, okay, the vertical axis for marginal revenue is going to be 0, 6. Okay, the horizontal axis for marginal revenue is going to be 3, 0. You must show mathematically how to get 0, 6, how to get 3, 0. It is a must. Okay, now, so 6 here, 3 here. Join the 2 points in order to get marginal revenue curve, which is given by 6 minus 2Q. The AR here is given by 6 minus Q. Okay, now, can you see? Whenever you want to draw any kind of graph using mathematical expression in one or in any kind of mathematical equation, what do you need to know? Number 1, check whether the graph upsloping or downsloping or both. Okay, how to do it? Differentiate the equation, okay, for the first time. Okay, and how do you know it is a straight line or not? Differentiate it again for the second time. Okay, so if it is 0, then it's a straight line. If it is not 0, it could be either 2 or 3. How to know whether it is 2 here or how to know whether it is 3 here? Recall back your business maths. I'm not going to explain to you in this chapter. Okay, so we are done with marginal revenue and average revenue. Can you see when we draw in the form of graph, the results is similar to the one using table previously, in which you can see clearly that marginal revenue is always below average revenue for all level of Q or quantity, isn't it? Okay, so now we are done with the graph of average and marginal revenue for monopoly. But here, for any kind of monopoly firm, the manager or the CEO wants to know what's the quantity and price that he should produce and charge respectively in order to maximize his firm's profit. Because any kind of business, the main objective is to maximize profit, isn't it? So there are two ways to do this. Okay, number one, using mathematical derivation. Number two, using graph. If you can recall back in your principle of microeconomics, you use a lot of graph to determine the area of profit maximization for monopoly and other types of imperfect market or firm in the imperfect market or industry. Okay, so we can also do this this time. So let me explain to you in the form of mathematical expression first. Once we are done with mathematical expression, then we go for graphical methods. Now we are looking at monopoly's output decision. For monopoly's output decision, it is not sufficient just to have marginal revenue and average revenue. We need to have cost functions as well. Why? Because for any kind of firm, regardless whether they are monopolies or not, when they decide how many output to be produced, what's the right price to be charged, they always decide in such a way that they want to maximize profit. Now, when they want to maximize profits, it is very obvious that profit contains revenue and also cost. So that's why I said earlier, it is not sufficient just to have revenue, average revenue, and also marginal revenue in any kind of output decision. We need to have cost functions as well. Okay, now in your principle, you already know that profit, okay, is basically revenue minus cost, isn't it? And output decision, it means quantity decision, how many quantity we want to produce. So let's write profit function in one specifically here. We know that profit depends on how many quantity we want to produce and sell, isn't it? Same goes to revenue, same goes to cost. Okay, so we can rewrite one in a more specific form as follows. Profit as a function of quantity is equivalent to revenue as a function of quantity minus cost as a function of quantity. So we have 2 here, equation 2. Now, for any kind of monopoly firm, if the firm wants to find out the right quantity to be produced and sold, okay, I'm referring to output decision. Like I said earlier, everyone wants to maximize profit. So we want to show you the monopoly's output decision, taking into account maximizing profit using mathematical methods. So we're going to use equation 12 extensively here in order to find out the output decision for monopoly in the mathematical form. Okay, what should we do here? Recall back your business maths, because for intermediate micro 2, you're gonna deal a lot with mathematics, especially simple differentiation like what we did earlier in the previous slide. Okay, so to maximize profit mathematically, we need to differentiate profit function into with respect to Q. When we differentiate profit function with respect to Q, we can find the right Q or the right output that can maximize this firm, okay, profit. So how do we do it? Differentiate profit function with respect to Q. Okay, this is on the left hand side. Therefore, we also need to differentiate anything on the right hand side of 2 with respect to Q. So how do we do it? Differentiate revenue function with respect to Q minus differentiate cost function with respect to Q. Okay, and then it doesn't stop there. Okay, because in order to maximize profit, okay, you look here. The maximum point, if you can recall back the drawing, if we have the drawing like this, where is the maximum? Maximum is here, isn't it? What happens here is that, okay, let's say this one is profit function. So the straight line that, sits on the maximum point here is the tangent, isn't it? Is a tangent to this profit function. So the straight line here, as you can see, okay, at this straight line, delta P over delta Q is equivalent to 0. Okay, so what does it mean here? If you have profit function like this, whenever you are at the maximum point like this, then you can see the slope of profit function is flat, isn't it, at the maximum point? Okay, and the slope is given by this, and this is similar to this, isn't it? So let's write this as expression 3. So this delta P, in Greek letter, this one is P, or in English they pronounce it pi. Delta P over delta Q is basically the slope of profit function. The slope of profit function at the maximum point is flat. When it is flat, the slope doesn't exist. When it doesn't exist, the slope equals to 0. That means for a monopoly to determine the right output to be produced in order to maximize profit, the slope of profit function must be flat. Flat means 0. Okay, so expression 3 must be equated to 0. Now, there's a specific name for this, When you differentiate a function with respect to something and then equate it to 0, then you know we are doing optimization. In this case, optimization refers to maximization. Okay, maximizing profit. Okay, then in mathematics, this one is what we call first order condition. Okay, so mathematically, if you want to decide the quantity that should be produced in order to maximize profit, first you must find the first order condition for profit function. In particular, you differentiate profit function with respect to Q here and then equate it to 0. Then it becomes first order condition. Okay. Any economic intuition in expression 3 here? Of course, yes. Okay, now delta P over delta Q, which is on the left hand side of, equal sign of expression 3, I'm talking about this. Okay, this one is the change in, profit due to one additional change in quantity. In economics, this is what we call marginal profit function, isn't it? Okay, so the slope of profit is actually marginal profit, and then equals. Now, on the right hand side, we have delta R over delta Q. This one is the additional revenue monopoly firm receives when they sell one additional quantity of product. So what is this? In the study of economics, this is what we call marginal revenue, isn't it? Minus. What about the last one here? The last one is delta C over delta Q. In economics, it is basically the additional cost that the monopoly firm has to incur when it produces one additional unit of product or quantity of product. And this one in economics is basically marginal cost. and then equals 0, 0. Now, this one is for, okay, can you see, can you recall back what you learned in your first year? All right, if I use 4 here, I rearrange it mathematically, then I can get something like this, yeah. Marginal revenue equals to marginal cost, because marginal revenue minus marginal cost is 0. All right, now this is the profit maximizing condition that you learn in Principle of Micro in your first year study, isn't it? All right, now, so only when marginal revenue equal to marginal cost, then the firm is so sure that it has maximized profit, because when marginal revenue equal to marginal cost, that means marginal profit is 0, isn't it? When marginal profit is 0, that means we are at this point, at the top point of profit function, or at the maximum point of profit function. What happens if we are here? Then marginal profit is positive, isn't it? Greater than 0. What happens if we are here? Then marginal profit is negative, less than 0. Okay? So the only way for this firm to maximize profit is when marginal profit equal to 0. And at that point, you can find what is the quantity. Now, what I have shown to you here is basically the derivation in the form of mathematics using generic function. So all of these are generic function. General. What does it mean by generic function? It is a function where it is very general. It doesn't show you any numbers except alphabet or Greek letters. All right. You can only know the sign, whether it is positive or negative, based on economic theory, and also based on the calculus that you have done. So that's why in the study of economics, any kind of mathematics that you use in the study of economics, you must derive or do calculus by following certain economic theories. Okay, so this is regulated mathematics, regulated by economics, theories, conditions, and also assumptions. Okay, so that's why mathematics involved in economic studies is what we call regulated mathematics. Okay, now I'm done with mathematical part of monopolist output decision using generic function. Now for you to find what is the quantity, okay, after you have equated the marginal profit equal to 0, if the specific function is given like this, P equals to 6 minus Q, and then you have cost function equal to what and what. When you do profit maximization like this, do differentiation, you can always find the exact amount of Q. But here, of course, we cannot solve it 100% because it's just a generic function. Then we may find, Q star equals to what? Okay. Now, we are done with mathematics part of monopolist output decision. Now, I'm going to show you the monopolist output decision in the form of a graph. Now, in the form of graph, if I draw it here, so we must have vertical axis, we also must have horizontal axis. Horizontal axis, we have Q or quantity of output. Vertical axis, we have price or money in the form of dollar, ringgit, pound sterling, or whatever kind of currencies. We also have drawn the average revenue function or demand function or price function. It is downsloping, and let's say it looks like this, somehow it looks like this. Yeah, this is just a general drawing. Okay, so this is average revenue equals to price curve equals to demand function. And we also have drawn earlier the marginal revenue function, and we know that it has to be below, okay, average revenue function. So let's call this marginal revenue. Like I said earlier, In order to find the quantity to be produced by these monopolists, it is not sufficient to have AR and MR only. We need to have the cost side of the function. What's the cost side of the function? First, recall back the condition of profit maximizing condition. Profit maximizing condition that we have found mathematically in the previous slide. It is MR equal to MC, isn't it? Okay. Now, we have MR, we have AR, but we don't have MC in this graph. Therefore, we need to put MC here. So draw MC. How does MC look like when you learn in the principle? Can you recall back that it looks like a J curve in it? So let's draw MC curve here. So MC is here. Okay. All right. Now, so profit maximizing condition MR equal to MC in the graph where it is when MR curve intersect with MC at this point. Let's use different pen so that you can see easily. Let's use red pen. Okay, it is at this point. Call this point point A. Can I find quantity that should be produced by this monopolist in order to maximize our profit? Yes. What should I do? From point A, I drag down the line until it hits horizontal axis or Q axis. So quantity should be here. Call it QM. Can I also find the price that should be charged by this monopolist in order to maximize profit? At QM, sure. At point A, you drag up the line until it hits price curve or average revenue curve. The price must be found on the demand curve or the price curve, not on the marginal revenue curve, because price is not marginal revenue. Price always above marginal revenue for every level of quantity, and this has been shown earlier in it. So price is here, PM. Can you see? All right. Is it possible for us to find profit of this firm? For the time being, it is not possible. Why? Because we don't have another graph or another curve that is average cost function. All right. Now, let's put average cost function in the graph so that it can facilitate us in determining the the profit of this monopolist firm when it produces at QM and charge the price of output at PM. So now let's say average cost curve looks like this. Now look at the way I draw, and you must follow this style of drawing. Why? Because for every part of the drawing, it has economic meaning. See here, it hits MC and then goes up. So what can you see here? I haven't talked to you about how to find the profit, after drawing, AC, but I still want to talk to you about the right way of drawing AC. As you can see, AC intersect with MC at this point, call it point B, when AC is at its minimum. AC can only hits or intersects MC curve when AC is at its minimum point. Otherwise, your drawing will be wrong. Okay? Remember this. If your drawing is wrong, although your answer calculation or whatever is right, the deduction will be applied because you don't understand the concept of AC and MC in the first place. So recall back, please do revision on principle of microeconomics about the drawing of AC, MC, and whatnot. Now, let's go back to our objective. We want to find the profit area. Okay, we know that this monopolist produce produces at QM and charge at PM. How to find profit here? At QM, cost for every unit is here, isn't it? Okay. So at QM, it hits AC at this point. Call it point C, yeah? Then this is ACM. Can you see? Look at this, PM and ACM. PM minus ACM, or the difference between price and average cost, is actually, profit per unit, isn't it? Because this times PM is greater than ACM, so we know that this firm is making profit. How can we find total profit? It's very easy. Total profit is actually, okay, PM minus ACM, which is profit per unit, times QM, isn't it? So the profit per unit is given by this rectangle. Okay? Okay, we have drawn the graph for monopolies for optimality. So let's recall back what we did. What is the rule to maximize profit for monopolies? The rule to maximize in the graph is MR equal to MC, isn't it? And this also implies profit equals to total revenue minus total cost at the maximum one. Okay, so from graph 2 results, what is the optimal level of output? Where is it on the graph? Okay, so in the graph, we didn't label it as Q star, we label it as QM, isn't it? Okay, now the next question is, what happens if the producer produce less or more than that optimal level of output? Let's go back to the graph. Okay, let's say we are talking about here Q1. Here Q1 is less than QM, isn't it? Or let's say we are here Q2. Here Q2 is more than QM. Now what happens to this firm in terms of profit and in terms of condition to maximize profit and whatnot? I want you to find the answer and also the justification for this or the explanation for this, yeah? Okay, so you need to read a textbook. Okay, what is the decision of producer if the output is less or more than the optimal level? So once you get the answer for this, you need to find the answer for this. It is very straightforward and it's very easy if you read the textbook. Now, so we have seen the graphical method. Have we seen the mathematical method? Yes, I have explained to you this. Now, let's look at this example. Okay, we have the first graph here, graph 3A. We have the second graph here, graph 3B. Okay, so what is it on the vertical axis of graph 3A? It's about money. It could be pound sterling, ringgit, or whatever. And then on the horizontal axis, we have quantity of output produced. Okay, in the first graph, we have revenue, profit, and cost. So let's say I draw profit first. Profit may look like this, yeah? So this is profit function. Where is the maximum? Maximum is here. Okay, now let's draw cost function. Now cost function starts here instead of 0. Why? Because when we don't produce anything in a firm, we still have a cost that we need to incur, that is fixed cost. So cost won't be 0 even if we don't produce anything, because we have purchased machine. So machine is there, the cost has been there even if we don't produce anything. Now, so the cost function maybe looks like this. Okay, this is the cost function. Now let's look at the revenue function. Could be like this. Okay, revenue function. Where is the maximum point? The maximum point is here. the quantity is QM, for instance. Now you look here, if I draw a straight line that is a tangent to the C curve, let me erase this, I draw it properly here. Okay. That is a tangent to the C curve, still mistake, erase it. Okay, then we drag up at QM, we may have another straight line as a tangent to the revenue curve. Okay, it's not very straight. Okay, so this. Okay, so this one is parallel to this one. What does it mean here? The line that is tangent at QM here for revenue and also cost, the two lines parallel, that means at QM, the slope here at point A and point B here are the same. And the slope of revenue function is what we call marginal revenue, isn't it? The slope of cost function is what we call marginal cost. When they are equals, parallel, that means they are equal, isn't it? And you can see they are equal or parallel at the maximum profit here. So this one is the maximum profit. Okay. Now, let's move to graph 3b. The graph 3b is just the same as the previous graph. I'm referring to graph 2. Now, so let's redraw graph 2 here. So we have average revenue and we have marginal revenue. And then look at the way I draw it, yeah? You have to be careful. So let's say MC looks like this. MC equal to MR at point C, for instance. When you drag up the line, the price is here, PM, okay? And then QM is here. QM here is similar to QM in 3A, isn't it? Okay, now let's say we have AC. Let's say I draw it this way. It's not nice. Let me redraw it again, because if I draw it this way, it resembles the meaning of pure competition, and I cannot do that because pure competition is not the same as monopoly in when it comes to profit maximizing situation. Yeah, yes, okay, so this is AC. So AC is here, ACM. Can you see minimum point is here hitting MC curve? Okay, let me use red pen to color the profit. So profit area is this rectangle, okay? And you can see in graph A, profit is at maximum here. In graph B, profit is at maximum also. Why? Because you have MR equal to MC at point C. Okay. Now, so at QM, okay, you see the distance here, revenue and cost. Revenue above the cost. Therefore, the difference is what? The difference is profit per unit, isn't it? Okay. No, profit, sorry. It's not profit per unit, profit. Okay. So, the difference between revenue and cost is actually profit or loss. Okay, so that's basic. Okay. Now, what's the point of showing you two different graphs here, 3A and 3B? 3A and 3B gives you the same results, which is QM, and QM is the optimal level of output produced by. Next, we move to the rule of thumb for pricing. Now, what's the need to have the rule of thumb for pricing when we already know that the conditions for maximizing profit is actually MR equal to MC? Why do we need to go for the shortcut? The rule of thumb for pricing is a kind of shortcut that basically can facilitate or helps the managers or CEO of a company to find, the price that can, help them to maximize profit without going through all the scratch of mathematics that we have done before. Okay, so now we basically want to translate the condition that marginal revenue should equal marginal cost into a rule of thumb so that it can be more easily applied in practice. Okay, so let's recall back the expression of marginal revenue. The expression of marginal revenue is basically given by this, but usually when I teach you guys, I always write it this way: MR equal to delta R over delta Q, yeah, instead of triangle here. If you can recall back, revenue is actually price times quantity, isn't it? Therefore, MR can also be rewritten as delta PQ over delta Q, isn't it? Okay. Now, recall back the definition of marginal revenue. It is the extra or additional revenue that the seller or the monopolist obtains by selling one extra unit of product or one extra quantity of a good or products. Now, we know that marginal revenue is downsloping. Why? Because the demand curve is downsloping. Now you look here. So the demand curve is downsloping, yeah? So this is AR or demand. Now, so let's say initially the price is here. Let's say the price is actually 10 here with the initial quantity demanded equivalent to 2. You already learned in principle of micro that for any monopoly firm, if they want to sell more, let's say from 2 to 3 here, yeah? Let's say 2 to 3. Then they have to reduce the price, let's say from 10 to 8, not only for one additional unit here. So we have one extra unit here, isn't it? But we have to sell it for all the, quantity. It's logic because in reality, just imagine, yeah, if we have buyer A and buyer B and I'm the seller, okay? So suddenly, the price reduces and then, the first comer is buyer A. Initially, before the price reduces, then buyer A needs to purchase at the price of 10, okay? And then next come, buyer B, and then the price reduces to 8. If buyer A wants to buy again, the same product, should you sell buyer A at 10 or 8? Just imagine if you sell buyer A the same product after the price has been reduced, you sell to him at 10 just because he came early before this, he paid at 10. Would he be angry? Yes, definitely. So the reduction in price, okay, must be applied to all quantity, not only to the additional quantity here, isn't it? All right, so remember this because this will affect the components of marginal revenue. Okay, now let's go back to the definition of marginal revenue. Like I told you just now, marginal revenue is actually the extra or the additional revenue that the seller obtains after selling one additional unit of products or goods. Okay, so this is it. Okay, now, do you realize that the marginal revenue or extra revenue from an incremental unit of quantity that is delta PQ over delta Q has two components. Okay, let's go back to this empirical example. Yeah, so let's say price, you want to sell more. Okay, so price falls down. What happens to marginal revenue, isn't it? Okay, so marginal revenue in this case, if we use simple maths, that we learn in the junior school, then you have this change in quantity, 3 minus 2, isn't it? Change in revenue. The new revenue is what? 8 times 3. 8 times 3 minus what? Minus the initial revenue, which is 10 times 2, isn't it? So what do you get here is, okay, 24 minus 20 over 1, isn't it? Which is equivalent to 4. Okay. Okay. We are done with the calculation of marginal revenue. We have found that the marginal revenue of increasing sale from 2 to 3 is actually 4. Alright, now let's go back to this. Let's go back to the components of marginal revenue. We already know that, number 1, producing one extra unit and selling it at price P brings in revenue of 1 times P. Okay. However, because the firm faces a down-sloping demand curve, producing and selling this extra unit also results in a small drop in price. Okay, so extra unit is change in Q or delta Q, and a small drop in price refers to change in P or delta P. So this reduces the revenue from all units sold. Okay, that is a change in revenue. Okay, which is equivalent to a small drop in price due to selling one extra unit multiplied by quantity. Okay, now let's go back to this numerical example to understand this. Yeah, let's look at the first one. Okay, the first one. So if you look here in the graph, this monopolist sells extra unit from 2 to 3. So one additional unit is 1, isn't it? So it refers to this. Okay. Now, so one extra unit and selling it at price P refers to 8, isn't it? So what happens here is that it brings in revenue of P, or in this case, 1 times 8, isn't it? Which is equivalent to 8. Alright, now, but the new price 8 here is not only applied to this additional, output or product. It also applies to the previous quantity, because now we are selling 3. Okay, we are selling 3 at the new price 8, not selling only one extra unit at the new price 8. Okay, so what happens these two here? Previously, if there is no change in price, we can sell at 10. But because there is a change in price from 10 to 8, okay, so we have to change to 8 for this, quantity 2, equivalent to 2. And because of that, you can see small drop in the revenue, isn't it, from 10 to 8 for this 2. Okay, now, so the small drop here for every unit is what? The small drop here is 8 minus 10, isn't it? For every unit is 3 minus 2, which is, minus 2 over 1, isn't it? So it means this minus 2 is actually referring to this. Okay, so because the firm or the monopolist is facing downsloping demand curve, so when it produces and sells this extra unit, okay, extra unit is this one, but it also results in small drop in price. That small drop in price is referring to minus 2, okay, and then which reduces the revenue from all units sold. Okay, so it's not only for the additional one, but the previous 2, if we use the new price, then instead of getting 10, we instead of selling at 10, we sell at 8. Okay, so what happens here? So how much is the drop or the change in revenue for these 2 when the price has dropped from 10 to 8? So basically is equivalent to what here? So 2, okay, refer to this quantity 2 times the small drop in revenue, all right, small drop in price, sorry, which is minus 2 equivalent to minus 4, isn't it? So this is the second component of marginal revenue. The first component gives you positive impact. The second component gives you negative impact or reduction. So what happens to marginal revenue is that you can find the net marginal revenue equivalent to what? Marginal revenue, in this case, is actually the first component plus the second component, which is 4. Isn't it the same as this? Okay. So, here, this yields the following. Now, marginal revenue on the most left-hand side is equal to this. Okay. So, the third terms here, I'll explain to you later. Okay. Now, you look here. Okay. So, this is the first component, which is 1 times P. Remember, in our numerical case is 1 times, 8. This is 1 extra unit after selling from 2 to 3 quantity. And this one is what? This one is the reduction in, or the small change in the reduction in revenue because of the small drop in the price, isn't it? All right, so this Q is 2 times what? Times minus 2. Minus 2 is this one. Okay, so this is the first component. This is the second component of marginal revenue. When you add both of them, that's why you get positive 4 for marginal revenue. All right. Now, let me erase this because I want to explain to you the third term in equation or expression 4 here. If we look at the third term, which is this, okay, how do we obtain this third term? So we are already here, all right. What you can do here is that multiply both sides of equation 4. Forget about this, yeah. I'm talking about this bit because I'm going to show you how this, can give you this, okay. So multiply 4 by P over P on both sides. So what happens is that MR equals to P times P over P, isn't it? Plus Q times P over P, and then times change in P, or in my writing case, should be delta, yeah? Delta P over delta Q, isn't it? All right, P over P becomes 1, isn't it? So we have P. Here, if we rearrange it accordingly, okay, then we can have this. What I do is that I bring this here and then this here. Then I can rewrite it this way. P, and then we have Q over P, and then times delta P over delta Q. I mean, we are just trying to change the position. Now, what we have done here, recall back our objective is to find the rule of thumb for pricing. This is to help, the manager or CEO of the monopoly firm to determine the best way to find the optimal price level that can maximize the profit. And this is a shortcut way. So the CEO or the manager of the firm doesn't have to go through all the mathematics that we are doing right now, just because, in order to find the right price to be charged in the market. Okay, now, so we are still in the process of getting rule of thumb here. If you can look at this here, which is this bit, yeah. Okay. Do you recognize this bit? Okay. Have you seen this before? P over Q times delta Q over delta P. Have you seen this before in Principle of Micro? Of course, yes. This is nothing else but price elasticity of demand, isn't it? So, what's the difference between, let's say, this one I call it A, this one I call it B? What's the difference between A and B? B is nothing else but the reciprocal of A, isn't it? So it is a reciprocal of elasticity, price elasticity of demand. Now, can you see? If you're very good in mathematics and you're very strong in economic theory, you can always modify any kind of economic equations in the form of mathematical expression to get simpler form of expression, economic expression, mathematical expression, to help non-economists, okay, to understand better about the economic theory. So here, as you can see, if we simplify it further here, let's say I bring this to here, yeah. Okay, then we can have MR equivalent to I factorize, okay, 1 plus what? We can have 1 plus, we just need to factorize this anyway, 1 over ET or reciprocal of price elasticity of demand, isn't it? Okay, so this is our MR. We have modified the MR expression, but we haven't found the rule of thumb for CEO to find the best way to calculate optimal pricing in order to maximize profit. So let's go back to our objective here. Okay, so we know that to maximize profit, okay, MR equal to MC. All right, so we have found MR equivalent to price times in bracket 1 plus reciprocal of price elasticity of demand, and then to maximize profit, equate it to MC. All right, now what I want you to do is to rearrange this so that we can obtain 5 or 6. Okay, so please do this at your own time. And if you look at 5 here, can you see what's the relationship between price elasticity of demand and MC? What's the relationship between, price elasticity of demand and also price? You look at 6 here, you can also rearrange 5 and get 6. This is just, bring left to the right, right to the left, and cross multiply. Now, can you see clearly what happens if MC increases? What will happen to price? Will price increase or not? Obviously, price increases. How do you know? Because if you take the first derivative of price with respect to MC, then you get something like this, isn't it? Okay, then this one is positive. So if MC increases by 1 unit, $1 or 1 pound, then price will increase by this much. Okay, so that's how you prove that it has positive relationship. You don't just see increase without proving it like this, yeah. At your level, intermediate micro, you have to explicitly prove it. If the equation is given or the mathematical expression is given, you have to prove it mathematically. Now try at home. What happens if price elasticity of demand increases? What happens to price? You do something like this also, but now instead of MC, you differentiate it with respect to price elasticity of demand, and then see the relationship, whether it is positive, negative, or none. All right. Now, let's move to the shift in demand curve. And the shift in demand curve in monopoly is there just to show you that monopolistic market has no supply curve. Before we go to this, very strong conjecture, let's recall back when we talk about supply curve. If we have supply curve drawn like this, quantity here, price here, then we can see supply curve is upsloping based on the law of supply. That means price increases leads to increase in quantity supply, isn't it? So if let's say initial price is at P naught, so we have Q naught. If it is at P1, increases to P1, then quantity increases to Q1 such that Q1 is greater than Q naught and P1 is greater than P naught. Okay. However, here I want to show you the shift in demand curve in monopolistic market, and there will be no one-to-one relationship between price and quantity produced. And why? Okay. Now, what does it mean by no one-to-one relationship between price and quantity produced? In the normal or ordinary supply curve, okay, if we have P naught, the associated quantity is Q naught. Then price increases to P1, the associated quantity is Q1. Can you see P naught is not sharing the same quantity, Q naught and Q1. P naught is for Q naught only, P1 is for Q1 only. This is one-to-one relationship between price and quantity produced. Now, so let's analyze this graphically. So we have the first one here, A. Okay, so we have price here and quantity here. All right. Let's say we have a simple MC curve, which is a linear straight upsloping MC curve, like this, just for simplicity of analysis. Now, let's say we have initial demand curve, which is D1, given by this. So the associated MR is MR1. Okay, MR1. To maximize profit as usual, MR equal to MC at this point. I call it point A. If you drag down the line, then you can have Q1, and then you can have price on the demand curve. Let's say P1. But let's say the demand curve shift downward to, let's say, somewhere here. Okay, so let's say somewhere here. Okay, call it T2, and the associated marginal revenue curve is MR2. Let's say somewhere here, MR2, and you can see when we have T2 and MR2, maximizing condition is at MR2 intersect with MC. Same at point A. If you drag down, so we have quantity Q naught. Q naught is equal to Q1. But if you drag up, the price is here, isn't it? P2. So P1, Q1, P2, sorry, not Q naught, Q2, Q2. But we know that Q1 equals to Q2. So this means Q2, Q1, isn't it? So both prices share the same quantity. There is no one-to-one relationship between price and quantity produced by this firm. So if there is no one-to-one relationship between price and quantity produced or supplied, then it's very hard for us to draw supply curve for this monopolistic firm. Let's look at the second example in graph B. So price is here, Q is here. Okay, so let's say again, MC curve is a straight line and upsloping, and the initial demand curve is given by D1, and the associated marginal revenue is MR1. So MR1 equal to MC is here. Then we can have P1 and Q1. Okay. So let's say we have a shift in demand curve. Let's say I try using blue color now. So let's say that shift is somewhere here from D1 to D2. Okay, and let's say the associated MR is MR2. MR2 equal to MC here. And then it hits the price here. Can you see? We have Q2, which is not the same as Q1, but P2 is the same as P1. So you have P1, Q1. You have P2, Q2. But here, you know that P1 equals to P2, isn't it? So both prices, right, quantity here, both quantity Q1 and Q2 shares same prices. Okay, so there's no one-to-one relationship. So it's very hard to draw, supply curve for monopolistic market. Okay, that's why monopoly firm doesn't have supply curve. Okay, I hope this is clear. Let's move to the effect of tax on monopoly firm. So here, the effect can be explained using the diagram. So let's put a price on the vertical axis and quantity on the horizontal axis. For simplicity, let's assume that marginal cost is constant over quantity. Therefore, if marginal cost is constant, that means marginal cost is just a horizontal line like this. Okay. Now, let's draw a demand curve for monopoly or average revenue curve. Let's assume that it looks like this. Okay, so this is demand curve, OER curve. Now, the associated MR curve looks like this. Okay, so this is MR curve. This is before tax. To maximize profit before tax, MR must equal to MC at this intersection. Okay, let's call this intersection point A. If you drag down the line, then you can have Q naught, and then drag up the line, then you can have P naught. Okay, so that's the price before tax. But let's say a specific tax of $T or T pound per unit is levied, and therefore this is sales tax. Yeah, so sales tax is levied on every quantity sold. Yeah. Now, this increases the cost of production, and the increase in the cost of production of course affect marginal cost. So what happens to the marginal cost? The new marginal cost will increase. such that it is equivalent to the initial marginal cost plus $t. Okay, so in this diagram or in this graph, what happens is that marginal cost shift upward to MC prime such that it's equivalent to MC plus T. So we need to find the new price and also the new quantity. Where is it? We must follow profit maximizing condition in which MR equal to MC prime at this point, call it point B. We drag down the line, we have Q1. We drag up the line, we have P1. Okay. You look at the difference between MC and MC prime. The difference is the amount of tax per unit quantity levied, isn't it? Now, after tax, the price increases from P0 to P1. So this is basically the change in price. Okay. Now, in this case, because the way I draw it, the change in price seems to be equivalent to the amount of tax, isn't it? Okay. If you draw it steeper, if you draw demand curve steeper and therefore MR curve steeper, can you figure out what happens to the change in price? Would it be the same as the amount of T, or would it be bigger, or would it be, smaller? So play around with this. Make it more elastic, the demand curve. Make it less elastic. And then see the change in price, whether it is the same, more or less than the amount of tax levied for every unit of output sold. Alright? Now, let's move to the next section. We want to look at the multi-plant schemes. Okay, so remember we are talking about the monopoly industry or market. So let's say we have one company. Okay, is it possible for a company that produces one product to have multi-plants or to have many factories? Yes or no? If you say yes, what the total output should be and how much of that output should each plant produce? Okay, so we can have the answer intuitively in two steps basically, yeah. But before that, if we say yes to the multi-plants, okay, so it means in reality, for instance, we talk about the production of car, okay, we are talking about one type of production of car, let's say Toyota. I'm just making up, yeah, this is not the real example. So we may have one plant or one factory in Indonesia, and we may have another factory or plant in Thailand, because these two countries, they have relatively cheaper labor costs compared to labor costs in Japan. Now, so it is possible to have multi-plants for one company of Toyota producing one kind of car, isn't it? Okay, let's say Toyota Camry. So the question is, we are very clear that Indonesia and Thailand, although they have relatively cheaper labor costs compared to labor costs in Japan, but both of them are not the same in terms of many things. If we compare Indonesia and Thailand, the cost of labor are not the same. Both of them have a cheaper cost of labor, but probably Indonesia has cheaper costs or Thailand has cheaper costs, but not that significant. Alright, so this is the reality. Now let's go back to the theory. Okay, so we want to, if I am the CEO, my question is, I have two factories or I have two plants, one in Indonesia and one in Thailand. How many cars should I produce from my Indonesian factory? How many cars should I produce from my factory in Thailand? So I must follow these two steps. Now you look here, step number 1, okay. Whatever the total output, it should be divided between the two plants or the two factories so that marginal cost is the same in each plant. Otherwise, The firm could reduce its cost and increase its profit by reallocating production. So what does it mean by this? So it means if I have two plants, let's say Indonesia is, the factory in Indonesia is plant number one, the factory in Thailand is plant number two, then the marginal cost for both of them must be equal. So MC1 equals MC2, okay? And let's say MC1 is greater than MC2. If I'm the CEO, what will I do? I won't produce in Indonesia, I'll produce in Thailand only, so I don't have multi-plant. All right? So that's what it means. So that's why, because if the cost is significantly higher in Indonesia compared to Thailand, why should I waste my money, producing in Indonesia? Because my main objective is to minimize costs and at the same time to maximize profit for my car production, isn't it? All right. Now let's move to step number 2. In step number 2, we know that the total output must be such that marginal revenue equals marginal cost. Now, can you recall back this kind of condition? Marginal revenue equals marginal cost. This is the profit maximizing condition, okay? And we cannot avoid this because if you don't follow this, that you are not at the optimal level of production and probably you may make losses or the profit that you earn is not the maximum one. So we must have total output. We must produce total output. That means total output from Indonesia plus output produced from Thailand equals to total output. This total output, okay, must be in such a way that MR equal to marginal cost. Otherwise, the firm could increase its profit by raising or lowering the total output. That means if MR is not equal to MC, then as a CEO of the company, I would adjust my output production until I get MR equal to MC, so as to maximize the profit. Okay, so now how do we do this? We can show this in the form of mathematical expression. Basically, I'll show you in the form of mathematical expressions that we go to the graph. Let's look at the first method. We look at the mathematical expression, the derivations in the of the profit maximization, and then the rule to find how many quantity to be produced in plant number 1 in Indonesia, and also how many quantity to be produced in plant number 2 in Thailand. Okay, so for a company, okay, so you have production from Indonesia and also production from Thailand. So the total production is QT. Okay, so the total profit will be coming from the production of all of this. Yeah, all right. So this is equation number 1. Okay, now, so then the total profit for this car company in Japan is given by this. All right, price times total quantity, okay, minus the total cost of production in plant number 1 in Indonesia, and also minus cost of production in Thailand, isn't it? So I call this equation number 2. In the in this slide, this one is equation number 2 is actually expression number 8. Okay, now remember we have 2 different factories in 2 different countries. So how does the CEO maximize the company's profit here? So we'll do it one by one. If you can recall back, in order to maximize profit, mathematically, you must, find the first derivative of profit with respect to quantity and then equate it to 0. Now, the moment you equate the first derivative of profit function with respect to quantity, we call it first order condition. In it. Now, however, in this case, because the company has 2 plants in 2 different countries, how can we maximize profit when we have 2 quantities from 2 different plants or factory? Let's do for the first plant in Indonesia. So In order to maximize profit from the first plant, then what you need to do is that to differentiate equation 2 or to differentiate the profit function with respect to quantity produced in Indonesia, which is Q1. So how do we do it? Delta P over delta Q1, okay, equals to delta total revenue over delta Q1, okay, minus delta CQ1 over delta Q1. Do you see any Q1 in cost function in Thailand here? No. Therefore, 0, isn't it? When we differentiate it, because it doesn't exist, then 0. Now, after you get the, differentiation for profit function with respect to Q1, this one is what we call partial differentiation, because we just differentiate profit function with respect to one variable, not two variables at the same time. And in this case, it's just Q1. So in order to maximize profit, this one has to be equated to 0. Why it has to be equated to 0? Because when it is 0, then you know that it is maximum point. How do we know? If you can recall back in the previous slides, I did mention to you that delta P Greek letter, or pi in English, this sign, over delta Q1 is actually marginal profit for this company when it produces Q1 in Indonesia, isn't it? Okay, and this marginal profit is actually the slope of total profit function or curve. The slope of total profit function or curve will be 0 or flat when it is at maximum point or minimum point. Okay, maximum point here, isn't it? Minimum point here. But because we're talking about profit, we don't minimize profit. We maximize profit. So here is where the point where we can maximize profit for this case. So this one is marginal profit. Okay, what about this? This is marginal revenue from plant 1, which is in Indonesia. Minus. What about this? This is actually marginal cost of producing the car in Indonesia. Okay, and then equate it to 0, isn't it? And as you can see here, okay, MR1 minus MC1 equal to 0. Then this implies MR1 equals to MC1, isn't it? Alright, and this is for plant in Indonesia. What about the plant in, Thailand? You should do the same for the plant in Thailand. So when you do the same for the plant in Thailand, I call this equation 3, and then this one is 4. You should get something like equation 3 and 4, but you change the symbol for Q1. Instead of Q1 here, delta Q1, you change it to delta Q2. Alright, so please do the same. So if you do it for, plant in Thailand, you're going to get something like this, isn't it? MR2 equals to MC2, isn't it? Okay, so, but remember, this is basically step number 2, from the previous slide. If you can recall back, this is step number 2. We know that the total output must be such that marginal revenue equals to marginal cost. But in step number 1, we must say that marginal cost is the same in each plant. So here, let's go back to this. So we know that in step number 1, we must have MC1 equals to MC2, isn't it? Therefore, instead of writing MC1 equal to MC2, we can replace it by having MC. Okay? So this one equals to MC, this one equals to MC. Alright, now call this one 5, call this one 6, call this one 5A. Now, by the virtue of 5A, then we have 5 and 6, yeah? And from 5 and 6, this implies that we have MR1 equal to MR2 equal to MC, isn't it? Okay, so alright, so in this case, this is the summary. We can also derive this result algebraically. Let's Q1 and C1 be the output and the cost of production for plant 1 and whatnot. In this case, if you look at equation 9, it uses triangle instead of delta. But I use delta because I'm used to it when I deal with mathematics, yeah? Okay, so, and after some derivation, then you can see MR equal to MC1, MR is equal to MC2 for plant 2. But here, I can also put MR1, I can also put MR2, isn't it? Alright, putting this relation together, we can see that the firm should produce so that MR equal to MC1 equal to MC2 equal to MC, isn't it? Okay, that's what I said. So, how do we put this in the form of graph? So now I'll show you in the form of graph. So now we draw it in the form of graph. Okay, so here we have pound sterling or ringgit Malaysia, and we have quantity here. Okay, so let's say demand in the market for monopoly looks like this. Okay, so demand equal to AR, and therefore MR must be below the demand curve MR. Okay. Now, let's say because we have two firms, one is in Indonesia and one is in Thailand. Let's say we have this MC1 for Indonesia and another one MC2. And therefore, if we total up, okay, it becomes this MC total. Okay. Now, so here, to maximize profit, it is, MCT equals to MR, yeah? Where is it at this point? So the total quantity is QT. Okay. Now, the price is somewhere here on the demand curve. But my main concern here is how many should be produced by plant number 1 and how many should be produced by plant number 2. So how to decide? Now, we know that, okay, MR must be equal to MC. And not only that, MC1 must be equal to MC2, isn't it? How to make both of them equal? Now you look here. For any quantity from 0 up to QT, alright, all of them must follow MCT equal to MR. So now, the MR will be here. I use red pen. So for any quantity between 0 to QT, alright, MR must be at this point. Let's call it MR1. After QT, then MR can fall. Can you see? Okay. So MR will be horizontal line between 0 and QT, because between 0 and QT, MR must be equal to MCT. Okay, which is this. Alright, now next, how many should be produced by firm 1 or plant 1? It is MR1 equal to MC1, which is here. Okay, how many should be produced by plant 2? It is MR1 equal to MC2. Okay, so this one is Q1, this one is Q2. So Q1 is this much, Q2 is this much. Therefore, Q1 plus Q2 equals to QT. Alright, so here we can see that in graph 6 here, we have two steps. The first one, MR must be equal to equals to MC to maximize profit. And not only that, MC for both of the plants must be equal. How do you know MC equals? MC1 is here, MC2 is here, which is equal to MCT here. So when they are equal, we equate it to MR1 here. Okay. How do we find MR1? Because initially we follow the profit maximizing rule, MR equal to MCT. At this point, therefore, any quantity between 0 and QT, MR must be MR1 or flat. Okay, so that's the way we should use to find quantity for each plant for the firm to maximize its own profit here. Now let's see why pure monopoly is very rare. Okay, so let's look at this example to explain this issue. So let's say we have a market in which we have 4 firms in that market. Each of them produces a toothbrush, and the market demand curve, which is the total demand curve for all firms, is given by 13. 13 is Q equivalent to 50,000 minus 20,000 P. And let's say total quantity in the market is 20,000. If we think that each of these 4 firms produces equal amount of toothbrush, then how many toothbrush per firm produces? So it's going to be 20,000 divided by 4, which is equivalent to 5,000, isn't it? Okay, so let's say the current market price is 150 and the demand is elasticity is minus 1.5. Minus here just shows you the negative relationship between price and quantity demanded. If it is 1.5, okay, that means it's elastic. This is the demand elasticity for market. Okay, and let's say we pick one firm out of these 4 firms and call it firm A, and firm A wants to lower its price below 150 because he thinks that if he lowers its price, so all customer would come to him and he can get more revenue and he can increase the sales, isn't it? So here, let's try to look in the form of graph. Okay, so we have 2 different types of graph here. Okay, so let's say the first graph where I showed you the demand curve for the market. Remember, the market has 4 firms, and the demand curve, let's say, looks like this. Demand curve for the market. Okay, and for firm A, this is market. For firm A, if you see here, the demand looks like this. Okay, demand for firm A, and therefore the marginal revenue must be below, and we have the MC curve for firm A. Now, we know that the price elasticity of demand in the market is minus 1.5. So ignore this minus sign because it just gave you the negative relationship between price and quantity demanded, isn't it? Okay, but if you look at the demand for the demand by customers or consumers for product toothbrush produced by firm A, it is a little bit flatter than the demand for market. So let's say elasticity of demand for the this firm A is minus 6. So you can see in absolute term, okay, the demand for market is less elastic than the demand for firm A, isn't it? And we are talking about producing toothbrush. Why is it so? Because for firm A, still have competitors, and those competitors are 3 firms, isn't it? So, logically speaking, if firm A wants to increase the price, maybe some of the customer will run away from firm A and goes to other firm B, C, and D in the same market of toothbrush here. Okay, now, for the current price before the change in, the increase or decrease in the price, for firm A, maximizing profit is MCA equal to MRA, which is here. Therefore, here is 5,000, isn't it, initial situation. And the price in the market, okay, is 150. And on demand curve, it is 150 as well. We don't put supply curve here, yeah, because it becomes a mess. Okay, as you can see, MR is here. Let's put it star, which is below the demand curve, which is below the price. Okay, marginal cost is also below the price. That means firm A is making profit, isn't it? Now, so suppose that firm A is deciding whether to lower its price to increase sales or not. So to make this decision, firm A needs to know how its sales would respond to a change in its price, isn't it? In particular, firm A needs to have some idea of the demand curve it faces, whether it is very elastic or not, as opposed to the market demand curve. Okay? Now, so we know that the elasticity in the market is 1.5, but the elasticity for firm A is 1.6, which is more elastic than the market demand curve, isn't it? Okay, so if firm A increases price, let's say from 150 to 160, we could imagine that the sales of firm A will drop. Okay, let's say from 5,000 here to 3,000. Okay, why? Because there will be some consumers buy more toothbrush from other firms because relatively cheaper, given that other firm doesn't change the price. Okay, but if other firms also increase the price from 150 to 160, perhaps the sale from firm A would only fall to 4,500 instead of 3,000. Okay, and for several reasons, sales would drop to zero. Okay, sales won't drop to zero because there will be some number of customers still prefer firms A toothbrush compared to other firms toothbrush because of different brand and whatnot. Okay, so they are willing to pay a little bit more. Okay, but if firm A wants to lower its price from 150 to 140, for instance, so we can predict that firm A can sell more toothbrush, isn't it? Perhaps instead of 5,000 here to 7,000 somewhere here. Okay, lower price. Okay, but then you have to remember other competitors might also want to lower their price, knowing that firm A lowering its price. Why? Because they don't want to miss the sales. Okay, so now what we can see here is that firm A's demand curve depends both on how much its product differs from its competitors' products and also on how the four firms compete with one another in it. So that's why it's very rare to see a monopoly in the reality because we still have competitors. Okay. We want to look at the monopoly power now. In the previous example, especially this, although we know that firm A has 3 other firms as the competitors, but still firm A has some monopoly power. Why? Because when firm A tries to reduce or increase price, there will be some customers stay with firm A. Okay. Now, then how do we know that firm A still has a monopoly power? So we are talking about measuring monopoly power. So remember, there is a very clear distinction or difference between a perfectly competitive firm and a firm with monopoly power. Because for perfect competitive firm or pure competition, price equals marginal cost. Okay, if you recall back in your study of principle of micro, quantity is here, price is here, and we have horizontal demand curve which is equivalent to R equal to AR with equivalent to price curve, and then you have MC here, isn't it? Okay, and this price curve also equals to MR equal to MC here, isn't it? Okay, so profit maximizing condition is MR equal to MC, isn't it? But because in pure competition, This is number 1, yeah. MR is actually equivalent to price, equation number 2. Therefore, from here, we can deduce that, okay, put 2 into 1, then we can have price equal to MC for perfectly competitive firm, isn't it? And what about the firm with monopoly power? We also know that to maximize profit, MR equal to MC, isn't it? But for firm with monopoly power, MR is not equal to price, isn't it? Because price or demand curve is always above NR. That is this, yeah? Demand curve or price curve is always above MR, isn't it? Okay, so you must remember this. Now, to measure monopoly power, there is one kind of index. We call it Lerner index. Okay. Now, Lerner index is actually measuring monopoly power calculated as excess of price over marginal cost. Okay, as a fraction of price itself. So, price minus marginal cost over price. I'm sure you have seen this equation before, yeah. And this equation, okay, let me rewrite it again. Price minus MC over price equivalent to Lerner index, or can also be rewritten as reciprocal of price elasticity of demand, isn't it? Okay, so this index of monopoly power is also 15. Now, so it means price elasticity of demand determines the monopoly powers. Can we show it in the form of graph here? Now, let's say we have, two different types of firm. Okay, the first firm, we have price here, we have quantity here, and we have MC that looks like this, and the demand curve looks like this. Okay, demand curve or AR curve. Therefore, marginal revenue looks like this. Okay. Profit maximizing condition says what? MC equals to MR. Where is it? At the intersection between MC and MR here. Call it point A. And if you drag down the line, so you have Q1 here, and then you have P1 here. At Q1, where is MC? MC is at point A. So this one is MC1. So you look at this distance. Okay, this distance is actually P1 minus MC1, isn't it? Okay. Now, let's say we have the second firm. This is firm 1, and we have firm 2. So the firm 2 is in another different types of monopoly market, yeah. So let's say MC looks like this, and the demand curve looks like this. Therefore, the associated MR curve looks like this. To maximize profit, again, MR equal to MC. Where is it? It's here, isn't it? Call it point B. If you drag down the line, you have Q2 here. And then where is the price? Price is here. Let's call it P2. Where is MC? When we this firm 2 produces at Q2, MC is at point B. MC is here, MC2. Okay, we level the vertical axis as P, horizontal axis as Q. Now you see the difference or the distance between P2 and MC2 here. So this one, P2 minus MC2, isn't it? Let me rewrite again the Lerner index. Lerner index is reciprocal of elasticity, price elasticity of demand, equivalent to price minus MC over price. Okay, so this one is actually this, and also this, isn't it? We call this as price markup. Okay, price markup. Now, the price markup is actually the difference between price and also marginal cost. Which one has bigger price markup? Firm 1 or firm 2? Firm 1 has lesser markup, isn't it, compared to firm 2? So, the demand for firm 2 is less elastic compared to the demand for firm 1. So, that means if firm 2 increases price, consumer is very inelastic, they won't run away. So when they don't run away, they have to, they have to pay higher price than before. When firm 2 increases price, isn't it? Then that's why firm 2 has more markup compared to firm 1. Now, from here we can learn that, okay, as long as the markup is bigger, then your learner index will be higher, okay, and as long as the elasticity is smaller, then your learner index is higher. The higher the learner index, the higher the monopoly power the firm has. Okay. Now, the next question is, what leads to monopoly power? In other words, what are the sources of monopoly power? In general, we have 3 different types of sources of monopoly power. The first one is the elasticity of market demand. Okay. The second one, the number of firms in the market. The third one is the interaction among firms. Now, the elasticity of market demand. So because the firms on a demand will be at least as elastic as market demand, but most of the time it's more elastic than the market demand, isn't it? We have seen in this example. Okay, now let's go back to this. So because the firm's own demand will be at least as elastic as market demand, the elasticity of market demand limits the potential for monopoly power. You can see from here, the higher the elasticity faced by firm 1, okay, the markup will be smaller. When markup is smaller, the profit is smaller. The monopoly power is also smaller, isn't it? Okay. Now, what about the number of firms in the market? If there are many firms, okay, so you have many competitors. So when you try to increase the price, thinking that you can increase revenue, yeah, because if you see here, revenue is equivalent to price times quantity, isn't it? Revenue can increase either by increasing price or increasing quantity or increasing both. But let's say this one doesn't happen, you try to increase price. Okay, this one is possible when there is no competitors. But if you have competitors or the number of firms is more in the market, then it is unlikely that any one firm will be able to affect price significantly, because the moment you increase your price thinking that you can increase revenue, consumer will run away from you and move to other 3 firms, for instance. Okay, so the more number of firms in the market, the less is your monopoly power. Okay, now not only that, if you have interaction among firms can be, 2 different types. Okay, so let's say we're talking the first one. If you only have 2 or 3 firms in the market, so each of them will be unable to profitably raise price very much if the competitors or rivalry among them is very aggressive. For instance, you try to increase price thinking of this, but this won't happen when your competitors, when he sees you're increasing price, he won't increase the price. He even reduce the price. So obviously, consumer from your, factory move to his factory buying his product, isn't it? So this is competition. But if you have different types of interaction among firms, instead of competing among each other, probably you want to, collude, and both of you agree to charge at the same price level, higher, then this kind of interaction is cooperation. Then you may have higher revenue, isn't it? So like I said earlier, there are 2 different types of cooperation among competitors. Either you want to compete aggressively, then you don't have much of monopoly power, or you collude. Okay, so in detail, if we talk about the first source, the elasticity of market demand. If we only have one firm in the market, then we call it a pure monopolist. So its demand curve is the market demand curve. So whatever consumer demand from your product, okay, then because you are the only one who sells the product, so the demand of your product is also the demand for the market. Okay, and if we look at the example in reality, The demand for oil is fairly inelastic because you don't find any other substitute other than oil, except recently, but not very widely used. For instance, if we talk about car, still a lot of consumers uh, buy petrol or buy gas to run their cars instead of buying electric cars or hybrid, isn't it? Because the cost is very expensive. So when OPEC, oil producing exporting countries such as Saudi, or those in Gulf areas such as UAE, could raise oil prices far above marginal production cost, then it means price minus MC is very high, isn't it? Markup of price over marginal cost is very high during 1970s and early 1980s. That they have more monopoly power. Okay. However, if we talk about the demand for commodities such as coffee, cocoa, tin, and copper, these are more elastic compared to oil because instead of coffee, you can have tea. Instead of cocoa, you can have coffee. Okay, and so on and so forth. Therefore, any attempts by producer or firms to catalyze these markets, to increase the price, to unite among the firm, to increase the price, to raise prices, always fail. Okay, so in each case, the elasticity of market demand basically means the potential or the possibility of monopoly power of individual producers. Okay, so the higher the elasticity of the demand, the more substitutes we can have, the less monopoly power you can have in the market for each of the firm. Now, don't be confused between monopoly firm and monopoly power. Yeah, monopoly power is about your ability to manipulate price. Monopoly firm is one seller in industry. Okay, now let's move to the second source of monopoly power. It's about the number of firms. So when we only have few firms in the market, okay, then we say that the market is highly concentrated. How to measure the concentration ratio in the market? So you try to check the index. Yeah, the index. The name of the index is very famous. Okay. Now, what makes a market has few firms? What makes other market has many firms? It's always because of barrier to entry. It's not easy to enter into the market given certain conditions. There are some conditions that can impede the entry by new competitors. For instance, okay, cost of production itself is very high. Okay, so not all firms can enter into the market because cost of production is very high. Okay, so and another example is like license. For instance, when it comes to electricity or water supply, government will only give license to few firms, not to all firms. So it becomes a barrier to entry to this kind of industry, and therefore we can only see few firms in the industry. So when firm can enter into this kind of industry, they have more monopoly power because others cannot enter into the industry. Now, the last source of the monopoly power is the interaction among firms. Okay, so like I said earlier, firms might compete aggressively, undercutting or reducing one another's prices so that they can capture more market share, they can get more consumers to buy their product or customers to buy their products. So what happens is that this could drive prices down to nearly competitive level. And because of that, because of this kind of interaction, then the monopoly power for each firm is lesser because you cannot manipulate the price. Every time you try to manipulate the price, other firm will also, reduce the price because they want to capture the market. Then you cannot control the market. Okay, but if you have different types of interaction among firms, for instance, you want to collude with other firms in the market, okay, so you try to limit the output or try to raise the price, then everybody agree, nobody wants to cheat, then raising prices in concert, altogether the same, rather than individually, is more likely to be profitable, isn't it? Because everybody has higher price, higher revenue, therefore more profit. So collusion can generate substantial of monopoly power because you are united. Okay. Next, we want to look at the social cost of monopoly power, and I'm sure you have seen this in the intermediate micro one. So this is just a revision for you. Okay. So when we talk about the social cost of monopoly power, we can try to depict it in the form of graph. So let's say we have price here and we have quantity here. Okay. So now what we need to do is, let's say we draw the demand curve, and the demand curve looks like this. Okay, so this is the demand curve equivalent to price curve equivalent to AR, because this is where we determine the price level, isn't it? And therefore the associated MR curve is here. Okay, so this is the associated MR curve. And we have the MC curve that looks like this. Okay, MC curve. All right. Now, in order for us to measure the social cost of monopoly power, we usually measure it by comparing with pure competitive, price determination. So for pure competition, okay, we know that to maximize profit, MR equal to MC. And we also know that MR is equal to price, isn't it, in pure competitive. Therefore, from 1 and 2, we can have price equal to MC, isn't it? Where is it on this diagram? Because if we want to measure the social cost of monopoly power, like I said just now, we need to use pure competitive firm to compare. So we will compare in the same diagram. So now I'm trying to put the pure competition price determination in this diagram so as to allow us to compare with monopoly firm price level. Then we can measure the social cost. Price equal to MC. So this is the MC curve. Where is price curve? It is demand curve, isn't it? Now, price equal to MC, what is it? At the intersection between price and MC curve, which is here. Okay? Let's call this point D. So where is the price for pure competition in this case? Because price equal to MC at point D. So the price for pure competition is here. Yeah? So we label it as PC. Now, look here. We have, in order to measure the social cost of monopoly power, we need to also know about the consumer surplus and producer surplus area. I haven't talked to you about the location of price for monopoly. Now, when price pure competitive firm is at PC, what is the area for consumer surplus? The area for consumer surplus, let's say here, here, and here. So it looks like a triangle, isn't it? It is, in fact, a triangle. So when we have pure competitive, so our consumer surplus area is basically P, D, PC, isn't it? What about the producer surplus? Producer surplus is the area of this, and this. Let's label this as E. So you can see that it is another triangle below the pure competitive price. So let's label producer surplus for pure competitive market as PC, D, and E. Now next, we want to put the price and also quantity for monopoly power. But before that, quantity for pure competitive firm is here. So we label it as QC. So for monopoly power, to maximize profit, okay, let me erase this one first so that I have some space to write. Now, for monopoly power, to maximize profit, the condition is still the same. MR equal to MC, isn't it? However, remember, for monopoly power, MR cannot be the same as price. MR is this one, price is this one, yeah? MR is this one, price is this one for monopoly power. So now MR equal to MC for monopoly power is at the intersection between MC and MR curve, which is here. All right. And then I call this point as point, let's say G. I'm just making up the point. Then if I drag down the line, then I have quantity for monopoly firm, monopolistic firm. And if I drag up the line, then it hits demand curve. Then the price for monopolistic firm is here PM. So this point, let's call it point H. Okay. So now, let's look for monopoly firm. What is the consumer surplus? So for monopoly firm, okay, the consumer surplus is given by the area PM. PH, another smaller triangle than before, isn't it? And what about the producer surplus? Producer surplus now, instead of the triangle of PCDE, okay, now remember quantity is here, QM. So producer surplus is given by any area above MC curve, starting from QM here, up to the price PM. So the area will be, for producer surplus is PM, H, E, G, isn't it? Okay. Now, so what happens to consumer surplus? Obviously, if you compare with pure competitive firm, consumer surplus for monopoly is smaller. Okay. So how much area has have we lost here? So the area that we have lost here is actually PM, H, D, PC. Okay. So we have change in consumer surplus given by PM, H, D, PC. It's a reduction, yeah, the reduction in consumer surplus. And this area is actually this rectangle and this, triangle. Let's call this rectangle as rectangle A. Let's call this triangle as triangle B. Okay, so it's equivalent to minus A and minus B. Why minus? Because reduction in consumer surplus after the change in price from pure competitive price to monopolistic price. Now, what about the consumer surplus? Has it changed? Yes, it has changed. Initially, the area was PCDE, isn't it? But now the area becomes PMHGE, okay? Or PMHEG, okay? So the change in producer surplus, what have we lost? Initially we have this, because quantity has moved from QC to QM. So we are losing this area, this triangle. Now this triangle, let's call this triangle as W. Okay. Okay. So I change this to W so that you are not confused. Okay. Now, so we lost W, but what do we gain from producer surplus? We gain A. So we have A, isn't it? Okay. So now, what is the net change? The net change is actually the change in consumer surplus plus the change in producer surplus. So here, let me put it here. So the net change is consumer surplus plus producer surplus, isn't it? Cancel, cancel. We are left with minus B minus W. Okay, instead of C, I change it to W. So it's equivalent to minus B plus W. We are losing B and W area. So this is what we call deadweight loss or deadweight loss. Okay, so that's why it becomes the social cost, because we have deadweight loss instead of social gain. Okay, Now, let's move to another problem of monopoly power. There will be a tendency to have rent seeking. So what is rent seeking? According to textbook, it is spending money in socially unproductive efforts to acquire or maintain or exercise monopoly. Okay, an example that you can think of. You know that once you have monopoly power, you become so powerful and you can always manipulate the price so as to increase your revenue and earn more and more profit at the expense of consumer, isn't it? So it looks lovely in the eye of business people, but it's actually, very hard to consumer. So sometimes, like I said earlier, monopoly happens because of, some industry, only few firms can enter because of license. And license is not easy to get. So sometimes some business people, they want to be in the monopoly power for a longer period of time. What they do is that they do rent seeking. For instance, they bribe the government officer so that the government officer will give, the license to them so that they can stay in that industry for a longer period of time and then can always manipulate consumer by charging higher price, but unproductively producing efficient output level. So the cost of bribery actually can be used for other productive, economic activities such as better, production of environmentally, friendly products or whatnot. But instead of using those resources of money for, environmentally environmental friendly product or other types of productive economic activities, this guy who is a monopoly in a monopoly firm uses money to bribe to the government officer so that he can get the license. So can you see spending money for the bribery? So spending money for the bribery is actually spending money in socially unproductive efforts just because he wants to acquire or maintain monopoly power in that industry. So it is wrong, very, very wrong. Okay, now let's move to another issue in monopoly industry. We call it price regulation. Okay, so because of this, and not because of this only, yeah, but because of social cost of monopoly power, as you can see, price charged by monopoly is higher than the price charged by perfect competitive, but they produce lesser than perfect competitive. So there's an issue for monopoly firm. In your study of principle of micro, you know that it is inefficient because they produce less than what it's supposed to be. Okay, so that's why, to a certain extent, we need price regulation. And price regulation is usually done by the government. Okay, so how do you explain this in the form of graph? Okay, let's say we have this graph and price is here, quantity is here. Let me change the color of the pen to black. Okay, now, so let's say we have, a R curve that looks like this and price that looks like this, or sorry, MR that looks like this. And let's say we have MC. Let me redraw it again because it doesn't look nice at all. Okay, so let's say we have MC and this is the AC so that we can show the profit area. Okay, AC. Without regulation, any monopoly firm will always maximize profit according to the profit maximizing condition, that is MR equals to MC at the intersection here between MC and MR at point A, for instance. Okay, so let's say quantity is here, QM. This is unregulated quantity and therefore unregulated price is here, PM. Okay, but let's say regulation is practiced for this monopoly firm. So what kind of price the government would impose here? Of course, it must be lower so that consumer can get cheaper price. Okay, if the price regulation is higher, then there's no point of having regulated price in it. Okay, so let's say the new price will be here. Okay, let's say here P1, and then quantity is here Q1. Can this monopoly firm survive? Yes, it can, because price is here Average cost is here, isn't it? So when price is above average cost, that means total revenue is still above, total cost, isn't it? Okay. Now, let's say government wants this firm to charge at MC. So Q is here, Q2, price is here. Now, can you see when price charge P2 is equivalent to MC, what is it? Price equals to MC. It looks like a pure competitive firm, isn't it? And Q2 here is actually pure competitive firm, uh, quantity. But let's say the government still wants the monopoly firm to charge even lower. Let's say here at AC. Okay. So the price here, P3 is equals to AC3, for instance, and quantity is here. Call it Q3. What happens here is that when price equal to AC, you multiply by Q, both sides, then you have AC, then you have total revenue equals to total cost, isn't it? So when price is regulated at AC, then it's just enough to cover the cost of monopoly firm. Can the government request or put condition to this monopoly firm to charge lower than AC? Let's say here, okay, price is here, but AC is here when quantity is at Q4. So AC is higher than price, isn't it, at Q4. What happens? What happens is that this firm is making losses. Can this firm survive? Cannot. But if the government still wants this firm to produce at Q4, what government should do? Okay, because otherwise the firm would be angry. Can you think the answer for this? Okay, please think the answer for this. So where is the price for pure competition? In this case, because price equal to MC at point D, so the price for pure competition is here. Yeah, so we label it as PC. Now, look here. We have, in order to measure the social cost of monopoly power, we need to also know about the consumer surplus and producer surplus area. I haven't talked to you about the allocation of price for monopoly. Now, when price pure competitive firm is at PC, what is the area for consumer surplus? The area for consumer surplus, let's say here, here, and here. So it looks like a triangle, isn't it? It is, in fact, a triangle. So when we have pure competitive, so our consumer surplus area is basically P, D, PC, isn't it? What about the producer surplus? Producer surplus is the area of this, and this. Let's label this as E. So you can see that it is another triangle below the pure competitive price. So let's label producer surplus for pure competitive market as PC, D, and E. Now next, we want to put the price and also quantity for monopoly power. But before that, quantity for pure competitive firm is here. So we label it as QC. So for monopoly power, to maximize profit, okay, let me erase this one first so that I have some space to write. Now, for monopoly power, to maximize profit, the condition is still the same. MR equal to MC, isn't it? However, remember, for monopoly power, MR cannot be the same as price. MR is this one, price is this one, yeah? MR is this one, price is this one for monopoly power. So now MR equal to MC for monopoly power is at the intersection between MC and MR curve, which is here. All right. And then I call this point as point, let's say G. I'm just making up the point. Then if I drag down the line, then I have quantity for monopoly firm, monopolistic firm. And if I drag up the line, then it hits demand curve. Then the price for monopolistic firm is here PM. So this point, let's call it point H. Okay. So now, let's look for monopoly firm. What is the consumer surplus? So for monopoly firm, okay, the consumer surplus is given by the area PM. PH, another smaller triangle than before, isn't it? And what about the producer surplus? Producer surplus now, instead of the triangle of PCDE, okay, now remember quantity is here, QM. So producer surplus is given by any area above MC curve, starting from QM here, up to the price PM. So the area will be, for producer surplus is PM, H, E, G, isn't it? Okay. Now, so what happens to consumer surplus? Obviously, if you compare with pure competitive firm, consumer surplus for monopoly is smaller. Okay. So how much area has have we lost here? So the area that we have lost here is actually PM, H, D, PC. Okay. So we have change in consumer surplus given by PM, H, D, PC. It's a reduction, yeah, the reduction in consumer surplus. And this area is actually this rectangle and this, triangle. Let's call this rectangle as rectangle A. Let's call this triangle as triangle B. Okay, so it's equivalent to minus A and minus B. Why minus? Because reduction in consumer surplus after the change in price from pure competitive price to monopolistic price. Now, what about the consumer surplus? Has it changed? Yes, it has changed. Initially, the area was PCDE, isn't it? But now the area becomes PMHGE, okay? Or PMHEG, okay? So the change in producer surplus, what have we lost? Initially we have this, because quantity has moved from QC to QM. So we are losing this area, this triangle. Now this triangle, let's call this triangle as W. Okay. Okay. So I change this to W so that you are not confused. Okay. Now, so we lost W, but what do we gain from producer surplus? We gain A. So we have A, isn't it? Okay. So now, what is the net change? The net change is actually the change in consumer surplus plus the change in producer surplus. So here, let me put it here. So the net change is consumer surplus plus producer surplus, isn't it? Cancel, cancel. We are left with minus B minus W. Okay, instead of C, I change it to W. So it's equivalent to minus B plus W. We are losing B and W area. So this is what we call deadweight loss or deadweight loss. Okay, so that's why it becomes the social cost, because we have deadweight loss instead of social gain. Okay, now let's move to another problem of monopoly power. There will be a tendency to have rent seeking. So what is rent seeking? According to textbook, it is spending money in socially unproductive efforts to acquire or maintain or exercise monopoly. Okay, an example that you can think of. You know that once you have monopoly power, you become so powerful and you can always manipulate the price so as to increase your revenue and earn more and more profit at the expense of consumer, isn't it? So it looks lovely in the eye of business people, but it's actually, very hard to consumer. So sometimes, like I said earlier, monopoly happens because of, some industry, only few firms can enter because of license. And license is not easy to get. So sometimes some people, some business people, they want to be in the monopoly power for a longer period of time. What they do is that they do rent seeking. For instance, they bribe the government officer so that the government officer will give, you know, the license to them so that they can stay in that industry for a longer period of time and then can always manipulate consumer by charging higher price, but unproductively producing efficient output level. So the cost of bribery actually can be used for other productive, economic activities such as better, production of environmentally, friendly products or whatnot. But instead of using those resources of money for, environmentally environmental friendly product or other types of productive economic activities, this guy who is a monopoly in a monopoly firm uses money to bribe to the government officer so that he can get the license. So can you see spending money for the bribery? So spending money for the bribery is actually spending money in socially unproductive efforts just because he wants to acquire or maintain monopoly power in that industry. So it is wrong, very, very wrong. Okay, now let's move to another issue in monopoly industry. We call it price regulation. Okay, so because of this, and not because of this only, yeah, but because of social cost of monopoly power, as you can see, price charged by monopoly is higher than the price charged by perfect competitive, but they produce lesser than perfect competitive. So there's an issue for monopoly firm. In your study of principle of micro, you know that it is inefficient because they produce less than what it's supposed to be. Okay, so that's why to a certain extent, we need price regulation. And price regulation is usually done by the government. Okay, so how do I explain this in the form of graph? Okay, let's say we have this graph and price is here, quantity is here. Let me change the color of the pen to black. Okay, now, so let's say we have, a R curve that looks like this and price that looks like this, or sorry, MR that looks like this, and let's say we have MC. Let me redraw it again because it doesn't look nice at all. Okay, so let's say we have MC, and this is the AC so that we can show the profit area. Okay, AC. Without regulation, any monopoly firm will always maximize profit according to the profit maximizing condition, that is MR equals to MC at the intersection here between MC and MR at point A, for instance. Okay, so let's say quantity is here, QM. This is unregulated quantity and therefore unregulated price is here, PM. Okay, but let's say regulation is practiced for this monopoly firm. So what kind of price the government would impose here? Of course, it must be lower so that consumer can get cheaper price. Okay, if the price regulation is higher, then there's no point of having regulated price in it. Okay, so let's say the new price will be here. Okay, let's say here P1, and then quantity is here Q1. Can this monopoly firm survive? Yes, it can, because price is here, average cost is here, isn't it? So when price is above average cost, that means total revenue is still above, total cost, isn't it? Okay. Now, but let's say government wants this firm to charge at MC. So Q is here, Q2, price is here. Now, can you see when price charge P2 is equivalent to MC, what is it? Price equals to MC. It looks like a pure competitive firm, isn't it? And Q2 here is actually pure competitive firm, uh, quantity. But let's say the government still wants the monopoly firm to charge even lower. Let's say here at AC. Okay? So the price here, P3, is equals to AC3, for instance, and quantity is here. Call it Q3. What happens here is that when price equal to AC, you multiply by Q, both sides, then you have AC, then you have total revenue equals to total cost, isn't it? So when price is regulated at AC, then it's just enough to cover the cost of monopoly firm. Can the government request or put condition to this monopoly firm to charge lower than AC? Let's say here, okay, price is here, but AC is here when quantity is at Q4. So AC is higher than price, isn't it, at Q4. What happens? What happens is that this firm is making losses. Can this firm survive? Cannot. But if the government still wants this firm to produce at Q4, what government should do? Okay, because otherwise the firm would be angry. Can you think the answer for this? Okay, please think the answer for this. We go into detail on monopsony buyer. Let's go back to the basic of pure competitive market. In pure competitive market, we have buyer and seller, and we have many buyers, we have many sellers. So let's look at competitive buyers versus competitive sellers. So here we have two frame of diagrams. The first one is for competitive buyer, one buyer, and the second one is for competitive firm. But remember, we have many buyers and sellers in the market, but the first and the second diagram here are just the representative of each of single buyers and firm in the market. Okay? Now, so let's say price is here, quantity is here. We are talking about competitive buyers first. Okay? For competitive buyers, they demand good. And when they demand good, they demand more goods or quantity if the price decreases, isn't it? So the demand curve is downward sloping. Okay. Now, the demand curve here shows you the price level for each of the level of quantity and vice versa, and it has negative relationship. And the demand here, the price here is actually the way buyers value the product. For any normal, human being, the more product you have in your hand, the way you value it becomes lesser and lesser, isn't it? Okay? Now, so the way buyer looks at the value is by looking at the price. So the price is actually the extra value for each of the quantity product purchased. Okay? So when I talk about the extra value, it is about the marginal value. Okay? Now, because of that, then demand curve is actually marginal value curve, isn't it? Okay. Now, but we know that we have many buyers and sellers in the market. If we go back to the market, okay, I draw it simple here. Quantity here, price here. We have total demand, we have total supply, isn't it? And then the market price is here. Let's call it P star. And the total quantity in the market is QT. Okay. Now, for this competitive buyer, if the price in the market is P star, the buyer has to take the price as it is, isn't it? Because following the demand and supply force here. So Regardless the quantity the buyer wants to buy, then the price stay the same at P star because the buyer is a price taker, isn't it? So here we have horizontal line, and then this horizontal line shows us the amount of money that the buyer has to pay whenever he buys, the product. This is the amount of money for every unit of product. Okay, so the amount of money or price that he has to pay is actually the expenditure to him, isn't it? It is his expenditure for every unit of quantity. Okay, for every unit of quantity, therefore, this kind of expenditure is what we call average expenditure. So the price is actually the average expenditure to the buyer, isn't it? Okay. Now, because the buyer has to take the price as it is, unless if there is any change in the demand and supply curve in the market here, then we can see the aggregate expenditure is horizontal line, isn't it? If the buyer wants to buy quantity Q1 here, price stay the same, aggregate expenditure stay the same. Okay, if we want to buy here Q2, for instance, price stay the same and aggregate expenditure stay the same. Aggregate expenditure, remember, is not the total expenditure. So if you purchase at P star and your quantity is at Q1, what is the total expenditure? P star times Q1, isn't it? Or AE times Q1, isn't it? Okay. Same goes to Q2. Now, so this is competitive bias, okay, demand and also the expenditure. Now, because price is taken as it is, so aggregate expenditure is also known as extra expenditure or marginal expenditure. When you want to spend one additional unit of quantity, you have to spend extra expenditure. That extra expenditure is the price that you have to pay one more time, isn't it? Okay. Now, how to determine the quantity that this buyer will purchase? So we have the condition here. To satisfy this buyer's utility or satisfaction, okay, then we must follow condition marginal value must equal to marginal expenditure. Okay, so marginal value is downward sloping, represented by demand curve. Marginal expenditure is actually the price curve, and it is horizontal because the buyer has to take the price as it is in the market. Okay, so determination is at point A. If you drag down the line, then you can have Q star. Okay, so that's the buyer side of pure competitive market. What about the firm side? Okay, we move to 13B, the firm sides here. On the vertical axis, we have price, and on the horizontal axis, we have quantity. Okay, this thing you have seen in your principle basically, yeah? Because for one firm or competitive seller in a pure competitive market or industry, they face upsloping marginal cost curve, isn't it? And because they take the price as it is, P star, therefore their demand curve, the demand curve for their product is at P star here only. Okay, and this one you already knew in your principle is equivalent to average revenue equivalent to marginal revenue. So can you see the expenditure, incurred by buyer in the first graph is actually the revenue received by the firm in the second graph. Okay, all right. The value for the buyer is actually the cost for the firm. All right. Now, so how to determine? MR equals to MC, isn't it, for this firm? Where is it at this point? I call it A prime. And then the quantity is Q star, for instance. What happens if in the market here, okay, the demand increases because of increase in the taste and preference? So let's say demand increases from D to D prime. Obviously, the price will increase to P1. What happens to the demand curve in the second graph? Then you can see it will shift upward, isn't it, to P double star. And same goes to buyer because buyer is also a price taker, not price maker. So move to P star. Can you see when price increases further, quantity demanded by this buyer decreases to Q double star. That is, normal, isn't it? And when price increases further to P double star for the firm, they are inclined to produce even more, isn't it? Okay. All right. So this is the, revision for competitive firm and competitive buyer in the market. All right. Now, let's go back to our objective here because we want to look at the monopsony. So for monopsony, how does it look like? Okay. So let's say we have this graph to explain the monopsony. So we have price on the vertical axis and we still have quantity on the horizontal axis. Okay. Remember monopsony, you have one single seller but many buyers in the market. Okay. Now, so here, the monopsony will face the supply curve. Okay. Monopoly, if you could remember in the previous class, this graph faces demand curve, isn't it? Or average revenue curve. But for monopsony, they faces supply curve. Now, we know from the basic that supply curve is upward sloping, isn't it? Okay, upward sloping. Okay. Nobody wants to supply more if the price decreases, isn't it? So can you imagine if you are here and you are monopsony, okay, you have Q1 and you want to move here, you still have to pay more, isn't it, from P1 to Q2, P2, okay? Because the supply is like that. Higher the price, okay, we can supply more. But you monopsony, you face them. You face their supply curve that looks like this. Okay, now let me erase this so that I can explain the rest. Okay, now the price that you have to pay as a monopsony buyer to the suppliers in your market, okay, is actually your expenditure, isn't it? What kind of expenditure? It is average expenditure. Why? Price is for one unit. Price is for one unit. So average expenditure is the expenditure for one unit, for every unit. So supply here is average expenditure. Now because price increases, quantity increases. Average expenditure increases, quantity increases, isn't it? So if average expenditure increases, what happens to marginal expenditure? Extra expenditure. When you want to spend more, you have to, you have to pay average expenditure more, isn't it? You want to buy more, you have to have more expenditure, movement along the supply curve. You have to have higher average expenditure, then you have to pay extra expenditure even more, isn't it? So if that is the case, then your marginal expenditure should be increasing, isn't it? Should be increasing. Now, if it is increasing, therefore, the marginal expenditure curve should be upsloping also, isn't it? Okay. But where is the location that we should put for marginal expenditure in this graph? We know that it is upsloping, same as supply curve or aggregate expenditure curve, but should it be above supply curve or below supply curve here? Okay. Now, if you can recall back the calculation of CGPA and GPA. GPA is actually marginal expenditure because it's every semester, yeah. Average expenditure is GPA because average for overall of your study for 4 years. Okay. Now, you understand that if this one for last semester is 3.8, so your CGPA will increase, let's say, from 3.1 to 3.2, isn't it? Okay. Now, if that is the case, what can you expect? Where is the location of marginal expenditure? Should it be above aggregate expenditure or below? It should be above. Okay, and should increase because price increases. So this is your marginal expenditure. Okay, but in order for you to determine what quantity you should purchase here from many seller, because you are monopsony, you have power to to manipulate the price. So what is the next curve that you need to have? Marginal expenditure must be met with marginal value. Okay, so marginal value is actually the demand curve for your product. The demand curve must be downsloping. And this is logic because you as a buyer, you don't want to pay more unless quantity, you don't want to buy more unless quantity is price is decreasing, isn't it? So demand, that's the way you value it. But in fact, when you spend, it depends on the supply of the firm, isn't it? Okay. Now, how this monopsony buyer decides on how many quantities should he purchase and at what price level? So the condition is still ME equals MV. Okay, marginal value equals to marginal expenditure. What is it? At the intersection between ME and MB, which is at point A. If we drag down the line, then you can have Q mono here for monopsony. Now, where is the price? Logically speaking, okay, the price that you have to pay, if you're the only single buyer, would you prefer to manipulate price in such a way that you have to pay higher or you have to pay lower? Obviously, you want to pay lower. So where is the location here? Is it here or is it here? It should be on the supply curve. So P mono. If you choose to be here, then it's not logic, isn't it? Although it is on the demand curve, but you must remember you are the buyer. It's not the seller demand of your product. You request seller to sell it to you. So seller supply to you. So the price must be determined on the supply curve here. Okay. So now you can see that. Let's put this point as point B. This one is A. You compare point A and point B. Okay. Now, the way you as a buyer value the product is very high, which is here. How do you know? Because this dot is on MV curve. The way you value is measured by marginal value curve. But then, in reality, you pay only this much. Can you see? So for monopsony, MV is always greater than AE or supply curve. Alright. Now, next thing is we need to compare between monopsony and monopoly. Monopsony, we have one buyer, many sellers. But monopoly, we have one seller, many buyers. So we want to compare between these two. How do we do it? We put both of them in the form of diagram. Now, in the first diagram, I put pound sterling or price. The same goes to second diagram. Now, in the first diagram, I'm going to look at monopoly. In the second diagram, we are looking at monopsony. Okay, for monopoly, you know that demand curve is downsloping AR. Okay, and this is the marginal revenue. Okay, associated with this AR. Let's say we put MC. Then profit maximizing condition is at the intersection between MC and MR at point A, and therefore Q monopoly is here. Where is the price? Should be determined on the demand or average revenue curve, and this is PM. And look here, if you want to look at this, where is the price of pure competitive market? The price of pure competitive market is price equals to MC, okay, or AR equal to MC. because this is a price curve, so it should be here, isn't it? At B. Where is the quantity? Drag down. You get the quantity QC. And here you have PC. Okay, that's how we compare monopoly and pure competitive firm. All right. What about, monopsony? Now, for monopsony, we know that we have supply curve which is upsloping, AE equal to supply curve, and therefore marginal expenditure is upsloping and above AE. Okay. Now, we have marginal value curve so that we can compare. Okay. So profit profit maximizing condition for monopsony is what? ME equals to MV. Where is it? At the intersection between ME and MV at point E prime. If you drag down the line, then you can have Q mono. Where is the price? Like I told you in the previous slide, it should be here, isn't it? P mono. Okay. Now, but if you were to compare it with pure competitive is price equal to MC. Okay. Price equal to MC. And MC is basically the supply curve. We call that MV is the price curve, isn't it? Demand curve. Okay. So for pure competitive, it is at this point B prime because MV is here considered as price, whereas MC is the supply curve. So PC and then QC. Okay, they are the same, isn't it? All right. So you can see that monopoly firm charges higher than pure competitive price, but monopsony buyer charges lower than competitive price. Okay, both monopsony and monopoly has lower quantity of output compared to pure competitive. Okay, for monopoly, they produce lower than QC, which is QM. For monopsony, the buyer purchase fewer than the competitive buyers, isn't it? Okay. Now, if you try at home, look at the second graph here. You flip it upward, then you can realize something interesting. Try to do that at home, flip it upward. Okay, and then you compare and contrast monopsony and monopoly after you flip the monopsony graph here upward. Okay, so I want you to try at home. Now we move to the monopsony power. We want to look at different types of monopsony power that depends on elasticity of supply and also some other things. Yeah. All right. Now, so we can use graph to explain this. Now, so we have two frames of diagram now. So the first frame of diagram, let's say, price is here, quantity here. Same goes to the second frame of diagram, price and quantity. Okay, so we have the demand curve, which is also known as marginal value. For the second graph, we also have the same types of demand curve. Okay. Now, let's look at the first graph. Let's say we have this kind of supply curve or average expenditure for this monopsony. Okay, so it looks like this. So supply, average expenditure. Let me make it a bit, flatter, because that's the purpose actually, to have two different types of diagram. Okay, So let's say this. Therefore, the associated marginal expenditure should be above, and this is ME. Okay, we already know that to determine the the quantity that this monopsony buyer will purchase is when ME equals to MV. Okay, it is at point A here, but the price is determined on the supply curve, and if we drag down this dashed line, we get the Q mono, and the price should be on the supply curve, P mono. Okay, but if you can see marginal value is here, P marginal value. Can you see here the way the monopsony value the product is higher than the amount of money that he has to pay, because the way he value is here, the amount of money per unit of product is here, so the difference is this much. Okay, P MV minus P mono. Okay, now let's move to the second graph. In the second graph, we have something like this. Okay, so this is the supply curve. Let me draw it nicer. It seems like it's a nicer tall. Okay, so it looks like this. Okay, which is average expenditure as well, and the associated ME should be above, which looks like this. Okay, so ME. So can we see the difference here between the first graph and the second graph? The first graph is a bit flatter, I mean the AE curve or the average expenditure curve. The second graph looks steeper. Now, we have the same condition, M equal to MV at point A prime. If you drag down the line, then you can have Q, I put Q star here to differentiate between Q mono and Q star. And the price that the monopsony for this case should be paying is at P mono star. But the way he values is MV here. So the difference is very huge, isn't it? Okay. And if we look at the second graph, we will try to compare the price of monopsony with the price charged in, in pure competitive or paid by the buyers in pure competitive. The price paid by the buyers in pure competitive is at the intersection between supply and demand, okay, which is here. Okay. Now, so this is PC, and you look at the quantity purchased by, competitive buyer is here, QC. Okay. And what about the first graph? PC should be here, isn't it? Okay, PC. And QC should be here. Can you see the difference between PC and mono and PC and mono star? Which one has the bigger difference? Of course, PC minus PC mono. PC minus P mono star, isn't it? So what does it mean here, class? When we have very inelastic supply, which is depicted in graph number 2, okay, the price of monopsony buyer compared with the price paid by competitive buyer is very huge in terms of difference, isn't it? But when it is very elastic as it is in the first graph here, the difference is smaller, isn't it? Okay, so why it is happening like this? Then we need to know about the sources of monopsony power. Now, the sources of monopsony powers, we have 3. Elasticity of market supply, the number of buyers, interaction among buyers. Can you recall back when we were talking about the sources of monopoly power? It was first the elasticity of market, demand. B, the number of sellers. C, the interaction among sellers, isn't it? So can you see it's just the mirror reflection now. Now, let's look at the elasticity of market supply. If only one buyer is in the market, and therefore we call it a pure monopsonist, its monopsony power is completely determined by the elasticity of market supply, isn't it? Okay, so you can see clearly from here. Okay, if it is very inelastic as in the second graph here, then you can see the difference between the price is very huge. But if it is very elastic, the difference is not that much compared to pure competitive. Okay. So if supply is highly elastic, okay, monopsony power is small and there is little gain in being the only buyer. Why? You can imagine if we have many supplies, yeah, many sellers, and you are the only buyers, and the sellers are selling raw materials for you, okay, and that raw materials is not only to can be used to produce your product, it can also be used to produce other types of products other than the product that you are producing. So if you charge them very little, they may as well they go to different markets selling their raw materials to others, buyers that are producing product different from your product, isn't it? So they have a lot of substitute. So if it is highly elastic, then your power becomes small because you cannot manipulate the price. You cannot charge. You cannot, uh, you know, pay lower price because they would run away from you because they always have substitute. Highly elastic. Okay. Now, now we move to the number of buyers. So if you're the only buyer in the market, okay, probably you can manipulate the price to some extent. But if the number of buyers is very large, no single buyer can have much influence over price because each buyer faces an extremely elastic supply curve. So that the market is almost completely competitive, isn't it? Because if you buy at lower price and you are offering lower price, other buyers may compete against you by offering higher price. So the seller won't go to you. So your monopoly power is not that, monopsony power is not that strong. And lastly, the interaction among buyers. The interaction among buyers. Just imagine if we have four buyers in a competitive, not very competitive, aggressively market. So every buyer will bid up the price close to their marginal value of the product. Can you see here? Okay. When you have many buyers, you try to, bid up the price until it's very close to the way you value it. Yeah. So, however, if those buyers compete less aggressively, okay, so let's say they don't really compete, but you are united among them and agree to be, to be one buyer so that they collude. And when they collude, they are united, they have more monopoly power to even, only offering lower price level. So prices will not be bid up very much and the buyer's degree of monopoly power might be nearly as high as if there were only one buyer. Yeah. Okay, so these are the sources of monopoly and monopsony. Now, is there any social gain or social loss for monopsony power? So let's move to this one. So we are talking about social cost of monopsony power. So monopsony, you already know that it purchase lower than the competitive price. So there must be inefficiency exists in this case. Yeah. So let's look at this. So let's say we use graph to explain this. So price is on the vertical axis and quantity is on the horizontal axis. Now, so we draw the demand curve or the marginal value curve, which is downsloping like this. Okay. Or the marginal value. Let's say it touches the vertical axis here. Okay. Now, we also have supply curve or aggregate expenditure, and therefore the associated marginal expenditure is this one. Okay. We already know that if we are in the pure competitive market, price purchased by buyer is at the point where supply equals to demand. And supply equals to demand is at point A, for instance, yeah? Small letter A. So I label this price as PC. And the quantity is here, QC. Okay, so you can see that the consumer surplus for pure competitive buyer is at PC, small letter A and P. Producer surplus is at PC, small letter A and, let's say I put it here, small letter B. Now, but if we have monopsony market in which we only have one buyer and many sellers, then the profit maximizing condition should be when ME intersects demand curve, or in other words, marginal expenditure intersects marginal value curve, and this intersection is at point C. Now, where is the quantity? Quantity purchased by monopsony buyer is at Q star. Where is the price? Obviously, it has to be on the supply curve when quantity is at Q star. Where it is? It is here, P star. Now, what happens to consumer surplus in this case? Consumer surplus now becomes this area, P, C. This point, call it point D, small letter d, and P star, isn't it? What has happened here? The consumer has gained this triangle. Okay, let me color it with red and call it capital A. But the buyer also loses this triangle. This is rectangle, yeah? This is triangle. And this area we call it capital B. Okay, so now consumer surplus, change in consumer surplus in this case is actually gain by area A minus loss of area B, isn't it? Now, what about the producer surplus? So let's look at the producer surplus new area. Okay, the producer surplus new area has been shrink. Initially, it was PC, small letter A, and B. But now, because the price has reduced from PC to P star, the new producer surplus area is actually P star, small letter d, and B. So, the producer surplus has reduced by how much? So, it has reduced by this trapezoid area. Okay, this trapezoid area. And this trapezoid area is actually area capital letter A plus this triangle. Let's call this triangle as capital C. Okay, so the change in producer surplus is the loss by the area of A plus C. The loss is a minus sign. So what is the deadweight loss? The deadweight loss is the net change in both consumer surplus and producer surplus, or the total change here. So the total change here is A minus B minus in bracket A plus C. Then you can see the deadweight loss cancel, minus B minus C. Or you can write it this way, minus in bracket B plus C. So we have the deadweight loss. Now, what does it mean by having deadweight loss? Having deadweight loss is actually showing us that the monopsony market is not efficient. Because if it is efficient, then the deadweight loss should be 0. And the deadweight loss is 0 when we follow pure competitive market profit maximizing condition. Okay. We move to the last part of this chapter, and here you can see the first one is about bilateral monopoly. Now, what does it mean by bilateral monopoly? We have one seller and one buyer. Does it really exist in reality? Try to think an example of this. Okay. Now, so it means you have monopsony power and at the same time, you also have monopoly power in the same industry or market. So both of them will tend to counteract each other. Okay. Now, how to determine the price and also quantity purchased or sold, and charge in order to maximize profit for each of them. This is not an easy task, and often they need to have negotiation among each other. Okay. Now, another issue when we talk about imperfect market is limiting the market power, because if we don't limit the market power, then the firm or the buyer can always manipulate the price in the market. Okay, and it leads to inefficiency and may also lead to the problem of distribution in terms of income later. So that's why we have what we call, some countries, they have what we call antitrust law. Okay, now what does it mean by antitrust laws? It's basically rules and regulations prohibiting actions that restrain or are likely to restrain competition. You just try to, put, conditions saying that you're not allowed to monopolize certain market because we want to have fair competition. Okay. Now, another thing here is about parallel conduct. Parallel conduct is actually a form of implicit collusion or secret collusion. In certain country, because you have antitrust laws, so you are not allowed to do collusion among firms. And if you're doing it, then you will be fined. Okay. Now, but still, some firms find their own ways to do collusion secretly, so we call it implicit collusion. Okay. So implicit collusion is in which one firm consistently follows actions of another. Okay. You're going to learn more on this, especially when we talk about price leadership and whatnot. Okay. Now, another one is predatory pricing. It is practice of pricing to drive current competitors out of business and to discourage new entrants in the market, so that a firm can enjoy higher future profits. There are some, methods in which you try to put a lot of barriers to new competitors outside the market, so that they cannot join the market and you become the monopoly all the time. Okay. So because you know how to cut costs, and they don't know how to cut costs. So when they try to charge higher price, you play the game by lowering the price, then they cannot survive in the market. So you are the only one who can survive in the market. So this is basically predatory pricing example. Yeah. So how to enforce all of the a law so that they don't do these kind of things? So in certain countries, we have enforcement of the antitrust laws, yeah. So through the antitrust division of the Departments of Justice, okay, through the administrative procedures of the Federal Trade Commission, in our case, MATRAD, in Malaysian case, MATRAD, and through private proceedings. Okay, sometimes you just, you don't have to go to the court, but you just discuss among each other, so that you don't have to go through to the, transaction cost of the court itself and whatnot. Okay, so this is the end of chapter 1, monopoly power.